Okay, dear colleagues, now we're beginning the last day of the Water Conference 2019, and our opening speaker is Professor James Oshman with interfacial water and the quantum information field. Please welcome.
This is wonderful. One of the best things that happened to me this year was I got an email from Jerry inviting me to this meeting. Thank you so much. I'm thrilled. This is an update on the quantum information field. This is me. And I'm very interested in anomalies. They're things that most respectable scientists don't even mention. And they require that you think outside of the box. And it's a nice day outside, so you can just go outside. You don't even need a box. So here's an anomaly, repeated observations with the MRI. They're hydrocephalics, or healed hydrocephalics, with 9/10 of their brain cells replaced with water. And they still function normally. This is a problem. This is a problem for the neuroscientists. Oh dear, what do we do now to try to figure out how the brain works? I talked to Hendrik the last week. He is sorry he isn't here. He's recovering from an illness, and he's getting better, but he couldn't come. But we talked about this, and he said easy water takes over the brain functions, an idea. And I talked to Glenn the other day, and he said cerebrospinal fluid contains a lot of protein that can structure water. And I looked it up, and sure enough, it contains plenty of protein. So the existence of these post-hydrocephalics, who seem to be missing most of their brain tissue cells, calls into question some of the cherished assumptions of neuroscience. This has been replicated many times. Dr. John Lorber ran the spinal bifida unit at Sheffield Hospital in England, and he studied these patients. And there were 60 people he studied who had 95% of their brains replaced by fluid. Of half of them had an IQ of over 100, which is considered average intelligence. Oh dear. One of the students at Sheffield University had an IQ of 126, passed a mathematics degree, had hardly any discernible brain matter at all, since his cortex was extremely reduced by hydrocephalus. And this is in this classic article by Lewin, Is Your Brain Really Necessary? I gave a talk somewhere, and there was a neuroscientist in the audience, and he said, oh, well, these are just high-functioning hydrocephalics. Does that make the question go away? Giving it a name? Does that solve the problem? No. So the orthodox view is that information relating to long-term memory is held within the brain in some chemical or physical form. And this fellow, who I cite, says we need to consider the possibility that memory is stored in some extremely minute subatomic form as yet unknown to biochemists and physiologists, or maybe that it's stored outside the body, extracorporeal, I can't pronounce that word, memory. And he refers to this as cloud storage. He suggests that maybe the brain is a receptor transmitter of some form of electromagnetic wave or particle, and I think that this is accurate. I think that memory is in the fabric of space and communicates electromagnetically, and the brain is a receiver, as Dr. Sheldrake has pointed out. A number of leading scholars down through the ages have said the brain is not necessary. Carl Jung said psyche is not in the head or the brain. And Dr. Sheldrake, along with a dozen or so other prominent scientists have concluded that mind, learning, memory, and the unconscious and consciousness are not confined to the brain. And these are not lightweights. These are serious academics. I work with energy medicine, and I can tell you that most schools of energy medicine teach distant healing. Prayer and distant healing work, and the idea that makes sense to me is that there is a quantum information field that connects the patient and the therapist regardless of location. There's a lot of skepticism about this flaky Twilight Zone, New Age, airy-fairy, gobbledygook, mumbo-jumbo. This happens. There's skepticism about global warming. I can prove it. That settles the case for global warming. Here's a young scientist saying that the vacuum of space may seem empty and boring. However, this void is actually teeming with activity, according to the laws of quantum mechanics. Fluctuations of electromagnetic fields are omnipresent, and they're there even in empty spaces. I forgot to set my clock. So here we go. Okay, we need young people like that here. So memory in the fabric of space, what a preposterous idea. Actually, it's an ancient idea. This is from one of the brighter lights in European academics, Irvin Laszlo. Mystics, meditators, and sages have long maintained that there exists an interconnecting cosmic field at the roots of reality that conserves and conveys information. Recent discoveries in vacuum physics show that this Akashic field is real and has its equivalent in science's zero-point field, or the quantum vacuum, that underlies space itself. This is a sea of fluctuating energies from which all things arise: atoms, galaxies, stars, planets, living beings, and even consciousness, and even us. This zero-point Akashic field is the constant and enduring memory of the universe. It holds the record of all that has happened on Earth and in the cosmos, anywhere, and relates it all to that which is yet to happen. And I read every page of this book, and I totally agree. I can add only a trivial few details to Laszlo's thesis. Here's another book by Laszlo, Quantum Shift in the Global Brain. He tells us of a radically new reality that's emerging. It's the reality that emerges from the existence of this quantum energy field, quantum information field. The only thing we should not be surprised at is being surprised. This decade is the first in history that offers the choice between being the last decade of a fading, obsolete world, or the first decade of a new and viable world. Anyone who still doubts that the world we live in is changing must be blind, obstinate, or just plain stupid. This reminds me of certain world leaders. In fact, some of them are involved in politics. You know the definition of politics: poly, many, ticks, blood-sucking bugs. In other words, we need to understand this new reality that's emerging from science and from the study of water and so on. And we need to do it now. We need to get going with this. The origin of biological forms is a problem which I consider to be the most important unsolved mystery, not only in biology, but in all of science. It's a problem that's widely thought to be solved, but it isn't. We've been taught that DNA is the blueprint for the body. It isn't. Here's a book, The Triple Helix. Why it has a double helix on the cover is a mystery that I have not been able to solve. Lewontin says, our ignorance of the generation of organic shape remains profound, despite the progress made by molecular studies of development. What the developmental genetics has done is to substitute a question that it can answer for one that it can't answer, but didn't tell us about the switch. Tricky. So, how did this kitten develop from a single cell? How did you develop from a single cell? What is the origin of the diverse forms in nature? Dr. Sheldrake talks about memory and morphology depending on morphic resonance, a resonance across time. I find his thesis to be extremely valuable. It was not greeted with much enthusiasm when it first came out. 1981, A New Science of Life, Nature magazine had an editorial that said that this book was a good candidate for burning. What an awful thing to say about a serious academic scientist's life work. This is appalling. And it shows the establishment position on how interesting the origin and form is to conventional science. So his concept was quickly rejected because such a field has never been measured. That's wrong. There is no evidence for it. That's wrong. Go to Dr. Sheldrake's website and you'll find fascinating information. It's inconsistent with data from genetics and embryology. Well, actually, obviously it's inconsistent because it's a different model. So here's Dr. Sheldrake. Memory and morphology depend on morphic resonance, a resonance across time. This could help us understand what's going on in the brains that have no brains and the origin of form. These are my motivation for studying this is I want to reverse engineer the morphogenetic field so that we can regenerate limbs and organs. We are silly enough to send people to the Middle East and have them blown up, and we're obligated to figure this out. We can put a man on the moon, we can create an atom bomb, we ought to be able to figure out how to regenerate limbs and organs, and it's not as widely studied as it should be. So I've been working on this, talking about this for a couple of years, and the pieces are gradually coming together. At the 2013 Water Conference, I suggested that easy water associated with the surfaces of molecules might match the impedance of the quantum information field with that of living matter, and thereby allow information to flow to and from living forms in the fabric of space. I gave an example of a molecule, an amino acid, lysine, and the hypothesis that spinning water molecules couple the morphic field to molecular structures, so information going in both directions to and from the morphic field. And this business of coupling, matching impedance is very nicely described in this patent by Charlene Boehm, Methods for Determining Therapeutic Resonant Frequencies. I recommend this patent. She describes how it's important to match the velocity of a frequency in air with the velocity of the same frequency in living tissue. And she has methods for doing that. So here's the update. How does the quantum information field and how does morphic resonance, how does it work? And I've gathered evidence. This is a multidisciplinary project. And I've described the structure and properties of an all-pervasive quantum information field that stores data of all kinds and that can energize a variety of phenomena. And this field, this information field, has infinite storage capacity, and it records events anywhere in the universe instantaneously. That's a remarkable statement, and if you want to know the evidence for that, I can tell you I'm an academic and I don't open my mouth unless I have references. So the information field is described. It's holographic, it's fractal, it's tensegrous. It obeys the mathematics of phi, or sacred geometry, and it has E8 symmetry. Each of these aspects is a study in itself, and I could spend hours on each of them. So this is the fitting together of the puzzle: the holographic universe, the fractal universe, the tensegrous fabric of space, phi, or the sacred geometry of space, and put all this together, and we have a pretty well-defined information field. And their holography, every part contains information on the whole: fractality, tensegrity, phi. My dear friend in the first row has kindly given me this wonderful model. I already forgot the name of my dear friend. But here it is. It's a great model for the fabric of space and the fabric of the body. It's a good model because the more you load it, the stronger it gets. When you have an impact, the impact is conducted through the matrix. When you pluck one of the tendons, the vibration goes through the whole system. And I noticed that if you hold this and watch the little tensegrity structure inside, you will see that it's vibrating. And it's vibrating with your heartbeat. Try it out. You'll love it. E8 symmetry. I really gasped when I saw this. This is a mathematical representation of the fabric of space. I can imagine that the morphic field is woven into this fabric. I don't understand the mathematics. Thank goodness there's Rodolfo who's going to help me. So here's a wonderful video called Hacking Reality. Look it up on the web and watch it. A layperson's guide to E8. Is there an 8-dimensional engine behind our universe? Join Marion Kerr. She's a movie star. Great to have a movie star in your video. As she explores a mysterious, highly complex structure known simply as E8, a weird 8-dimensional mathematical object that for some strange reason appears to encode all of the particles and forces of our 3-dimensional universe. This is a work in progress. These people are very serious. They're in LA, they're quantum physicists, and this is not the end of the story, but it's a very good beginning. Here is Marion underwater. Let us talk about infinity. And for water, think empty space. Imagine opening your eyes and finding yourself surrounded by water and you cannot remember ever not being in that water. Read space. Cannot remember not being in space. The first question you might ask is, how did I get here? You've always been there. What do you mean always? When did I enter the pool? You've never entered the pool. You have always been in the pool. We have always been in space. Okay, but where was I before I was in the pool? That's the first question. There is no before in which you were not in the pool. There is no before, and there's no after. You have always been in the pool, and then, to emphasize, she growls, always. So what is this? Well, I was talking to a friend, and we had lost a dear friend, and my buddy said, "It's okay. He died, but he didn't go anywhere. Still here." That's what we're talking about. This is why I don't worry about my dear friends when they die, or myself, because we stay here. So here's E8 symmetry, the hidden symmetry of nature. This is mathematics. This is sacred geometry. This is where I take my clothes off and always have to undress during a talk. I wear this T-shirt, and a muscle testing expert tested me, and this makes me stronger. And the colors are important. I have one that's black and white. It's not nearly as good as the one with the color. And this is the salsa I spilled on my shirt in Oslo last week. And that adds more energy to my T-shirt. So I didn't wash the salsa off because it's giving me even more energy. Sacred geometry is actually the geometry of space. The reason it's sacred is it's such a powerful symbol. It's found on temples in every culture, ancient temples in every culture in the world. Gravity waves have been detected just a few years ago, and this was a very important part of the story, and you'll see why. This woman, her name is Kelly Holly Brockelman, and this is a TED talk from Nashville. She's an astrophysicist. She specializes in the study of black holes, and you will see that a friend of hers made this dress for her. It has woven into it the waveform of the first gravity waves detected. This was an incredible event in the history of astronomy. It was the Laser Interferometer Gravitational Wave Observatory, LIGO, supported by National Science Foundation, Caltech, and MIT. Hundreds of thousands of scientists, millions of dollars, many years of very careful research, and it paid off. It was a success. And here are the two observatories we have in the United States. One is in Hanford, Washington. The other one is in Livingston, Louisiana. And you can see it has very long arms, and light beams are sent down these two arms, reflect off mirrors, and come back and are measured. And so far, this combination, you need two observatories. They're actually cropping up all over the world now. It's the greatest advance in astronomy in recent years. And as of December 2018, they've made 11 detections of gravitational waves. These are waves created when very massive objects in the universe do something, like bang into each other. And Einstein predicted that they would exist. So here they are, and the gravity waves change dimensions by 1 part in 10 to the 21, equivalent to a 10,000th the width of a proton. This is the smallest measurement ever made. What technology? The mirrors are the smoothest ever made. They weigh 90 pounds each. They're at the ends of the arms, and they're suspended by silica threads that are twice the thickness of a human hair. And they have to pump all the air out of the interferometer. They use very high power laser with enough energy to power 1,000 homes. So they pump out enough air to fill 2.5 million footballs. I guess they send them to Europe where football is. Anyway, it's the best vacuum in the world, 1/trillionth of an atmospheric pressure. The other big vacuum is at CERN, the Hadron Collider, where they discovered the boson. And here's the European Organization for Nuclear Research, this enormous project. So, Kelly Brockelman says this: you are matter, you move. All through life, you make gravitational waves. Every move you make, every choice you make throughout your life is making gravitational waves, propagating away from you at the speed of light. Actually, it's very much faster than the speed of light. The Russian scientists have described this. Long after you're gone, that imprint you have made in the universe will exist. Does this sound like it might be memory? Your choices matter. They're going to be a part of the universe. When I give talks on energy medicine, I tell people that energetic hygiene is very important. Your thoughts are important. Your thoughts affect your body, and your thoughts affect the bodies of people near you. Those energetics are describable by just simple classical electromagnetic theory. There's a book. You don't have the luxury of a negative thought. You don't have to read the book. The whole story is in the title. You don't. The things that we do now are going to be traveling away from us as waves in the cosmos, eventually reaching those stars we see in the Milky Way. So there's the Milky Way, receiving our thoughts, our movements, everything we do, everything that anybody does anywhere. This is from this year, April of this year. The universe probably remembers every single gravitational wave. What a remarkable statement. And this is in a New Age journal called Physical Review D. Actually, this is a prominent academic peer-reviewed physics journal. How about that? The authors showed that after the waves pass, they might leave a region slightly altered, leaving behind a sort of memory of their crossing. The researchers termed these changes persistent gravitational wave observables. I think we're getting close to Dr. Sheldrake's morphic field. So the detection of these gravity waves, which Einstein predicted 100 years ago, has contributed an important picture of the dynamic structure of space, and remarkably, something that we can connect to biology and consciousness. And the quantum information field, to me, explains many of the anomalies that have seemed to be totally mysterious. And it has lots of names: the quantum vacuum, quantum plenum, quantum zero-point field, subspace, the world substance, the cosmic plenum, ground state of the universe, universal consciousness, mind, higher mind, the mediums talk to the other side, the divine, the all, lots of different names for the same thing. In terms of the components, you can study each of them individually. There are lots of scholarly books, for example, on the holographic nature of mind and space, the holographic universe. These are serious books with lots of detail. Ask a physicist about the structure of space. There are two kinds of physicists. One kind will say, space doesn't have any structure. It doesn't have any structure because we don't have any equations for it, as if nothing can exist unless you have equations. That's completely wrong. The other physicist might say, the vacuum is the central fundamental basis for the physical description of reality. It may become the foundation of the next era of the physical world picture. So it's like everything else. There's a conventional view that everybody who's been to school knows and is incomplete. Here's a book. You want to see equations? Here they are. An overview of twistor string and quantum theory, mapping Minkowski space to twistor space. This wonderful book has tons of equations and explains each of them in language that an ordinary person like me can understand. Here's another book. This is the Geometric Universe. This is the life work of Roger Penrose. And they talk about all these terms none of which I understand at all. So I need help. That looks to me like Kähler manifolds, the cup product, differential geometry, inner product of the tangents. With all these terms, this enables mathematicians to maintain their academic tenure because they're the only ones who know what they're talking about. And I don't understand any of it. Thankfully, Rodolfo is going to help me. So here's some examples of the fabric of space. This is from a popular book by Carlo Rovelli, a bestseller, 7 Brief Lessons in Physics. And you can see the curvature of space, which Einstein, 100 years ago, described as the cause. In fact, it's not the cause of gravity, it is gravity. Objects move along the curvature of space-time. And Rovelli put a little fine structure in it. I'm glad he did, but that doesn't really represent what's going on. Here's the Dirac sea, particles that form, annihilate each other, and disappear. This is going on continuously. The sum total of what's happening is nothing, but a lot is going on. I recommend reading P.A.M. Dirac's Nobel lecture. In fact, that's how I learn. I read the Nobel lectures, and if I don't understand them, I read the Nobel press releases that explain why the prize was given for this particular discovery. And they're in English that I can understand. Here's another view, pentagons. This is another form of sacred geometry. In biology, we once, a long, long time ago, had a theory of the homunculus. Every sperm contained a miniature organism. We don't think that anymore. And so the morphic field is not a homunculus. It's a code that can be decoded, I believe. Homeopathy. I was very excited when I saw Dr. Montagnier do his dilutions. The problem in homeopathy, the reason it makes no sense, is the more you dilute something, the more potent it gets. Well, that's ridiculous. Anybody knows that that's nuts. But when I saw this, I got very excited because the vortex mixer is perfect for spinning molecules and getting them to emit their electromagnetic fields into the quantum vacuum, which has a vortical structure to it. So this excited me, and I got the idea, the instant I saw him demonstrate this, I got the idea that what homeopathy does, what it may be doing, is not putting information into water, putting information into water and then into the quantum vacuum, so that the remedy is present everywhere. And this would explain why the more homeopathy is done, the more potent it gets around the world. Homeopathy is the most powerful medicine, and in some countries they're trying to abolish it. Hundreds of millions of people rely on homeopathy. Biology confirms the vortex structure of space and light. This is the corneal stroma, the thick layer underneath the corneal epithelium, and it has a plywood-like structure. The collagen fibers in one layer run in one direction, the next layer it's slightly offset, and the next layer is offset, and it's ideally structured to allow light vortexing into the eyes. And it turns out light spirals into both eyes in a right-handed helix, which violates the law of symmetry in the human body. The two eyes should have different properties. They have the same property, and the reason for that is it enables you to see. It makes a big difference. So both the fabric of space and the fabric of the body have spiral grains. We know this from Vladimir Ginsburg's incredible books, The Spiral Grain of the Universe. He's written 5 books on the spiral grain of the universe. As far as I can tell from Amazon, nobody reads these books. They're great books. Somebody needs to read them. In fact, the latest one, I have a section that I wrote. Sacred geometry, actually, technically, we call it the geometry of the quantum vacuum. The mathematics of space is the golden ratio, or phi. This number has been studied by intellectuals down through the ages, from Euclid, ever since Euclid, trying to figure out what's going on here. And a recent study, 2010, a group of European physicists reported a decade-long study showing that solid matter has quantum properties defined by the golden ratio, famous from art and architecture, and these findings were published in Science. And what they did was they produced one atom thick chains of a magnetic material, cobalt niobate. These were like guitar strings. They were magnetic, and the magnetism arises from the aligned spins of these magnetic atoms, and they plucked the strings with the magnetic field, and what happened was we found a series of resonant notes. The first two notes show a perfect relationship with each other. Their frequencies are in the ratio of 1.618, the golden ratio, famous from art and architecture. And one of the scientists says, it reflects a beautiful property of the quantum system, a hidden symmetry, actually quite a special one called E8 by mathematicians, and this is its first observation in a material. Here's another example, atomic, ionic, and Bohr radii linked with the golden ratio. Here's the Mandelbrot set. Mandelbrot was totally disrespected by geometers because it was different, and it turned out to be very useful in making movies like Star Wars. Creating amazing images. Space is recursive. The pattern repeats in an infinite series of scales. If you've ever been in an elevator with a mirror on both sides, I always try to see the last one, but it just goes off into infinity. So all of these stories fitting together. Thank you. And if you have questions, comments, or want to help me, there's my email.
Thank you, Dr. Oshman. Very impressive. Do you have any questions?
Hello, it was very impressive. But I have a question. Coming back to the brain and the easy water, yeah? Can we tell that if we can change potentially all the water, drinking water, to the easy water, it will help in the growth of understanding information fields, or the better sensitivity for human?
Yes, and I think it'll make us all a lot healthier. It appears that Wi-Fi totally demolishes coherence in our bodies, and that's a serious problem. We need coherent water within us.
Thank you very much.
Any other questions?
Jim, I've great talk, but I had inconsistency here. If you're saying that the geometry of space-time and the quantum information field is what you said it was pentagonal, how could it resonate with easy water, which is hexagonal?
I don't know. There's one there. That was, by the way, my favorite phrase when I studied to be a professor at the university. The most important thing I could say to the students is, I don't know.
I kind of have two questions, and they might tie together, but it has to do with the fractals, it has to do with heparin sulfate, and it has to do with the 5s and the 6s. Because I see a lot of molecules that have 5-sided and 6-sided rings that carry sulfate, that transport sulfate in the blood. All the sterols, cholesterol, and all the hormone derivatives, and all the neurotransmitters, dopamine and serotonin, they have a structure. Many of them have a structure, even vitamin C, 6 and 5, or multiple 6s and 5s. I suspect it has something to do with maybe, and I'm very speculative here, getting into the structured water and modifying it so as to activate a release of maybe hydroxyl radicals or protons or something to energize the water. So maybe there's some way of energizing reactions such that the sulfate could be handed off into the extracellular matrix. So the theory is very speculative. These molecules transport sulfate and they deliver it, for example, to the brain. And then they allow it to be easily transferred from that molecule into the heparin sulfate matrix. The other piece of the puzzle is that inside the cerebral spinal fluid in the ventricles, the brain ventricles, it's known that the structures there are fractals, and they contain lots of heparin sulfate. And it's also known that autistic kids have a deficiency in heparin sulfate in those ventricles. And I suspect that deficiency connects to their defective brain capacity. Any comments on that?
I just am so thrilled with your analysis, and thanks for more. That's all I can say.
Is that all? If that's all, then thank you so much again, Dr. Rushman, and we're going on.
Okay, dear audience, we are going right away to the next speaker. It's Ernst Zürcher, and he will talk about water, the vortices, and in trees. Yeah? Thank you.
Thank you. At a very macroscopic and simple level, I would like to speak and to show and to propose to see how trees deal with water. Maybe it's exactly the opposite, how water deals with trees. And I'm going to end in phi mathematics or geometry, sacred geometry, which is also demonstrated by trees in a very obvious way. Water and vortices in trees. Water can be considered as quantities which travel trees, which are transformed by trees, but also in terms of movement, which are very special in trees, and also in terms of qualities. And here we will see how much our discoveries concerning easy water, concerning vortices, concerning geometry are coming together in what trees show. Trees can be seen at the individual level, but I wouldn't like to stay at this stage. I would like to show how we can make the opposite, than analyze the thing, than decompose the things. It is always interesting to ask to what bigger reality does something belong. And for the trees, we can do it exactly in the same way. But starting with a single tree, just one fact. The oldest trees on the world have more than 5,000 years as age, as living beings. And they are still, it's for example, an impressive yew tree in the center of Scotland in Fortingal. And this yew tree is more than 5,000 years. And it's impressive how this tree is in splendid vitality. You think you are near a small forest of young trees, but it is an old tree which was sacred in the past, in pre-Christian period times. And it's still here. And here, first question, what does this tree have as memory, having been here for such a long time? But let's ask, what do the trees belong to? And we can see a tree not only as an organism, because you can uproot a tree and plant it in another place, and it will start again its life. You can also consider that a tree is an organ of an organism at a higher level. And this organism is very well known, it's a forest. And trees are organs of the forest, because a forest is not just by chance combinations of trees. We have selective associations between different species of trees, and we call that that's plant sociology. There are rules how trees grow together to form forests, and the forest has a certain structure, and the structure implies the role of a membrane. The membrane is the most important attribute of organisms. It's even more important than the nucleus, because you have organisms, cells without nucleus and some with nucleus, but always you have the need of a membrane. And the membrane is, in fact, where the communication with outside and translation with inside happens. It can be told, Bruce Lipton had this expression as the place of the intelligence of cells or of organisms. And for us, it's the same. Our organs of senses are originated from our ectoderm in the embryology. And here the same. The envelope of the forest is much more important than we think, and the forest edges are very important. And here you have the largest biodiversity. And inside a forest, you have another atmosphere than outside. You have another way of, another capacity of storing water. And this is actually the most important property or function of the forest, looking at the geoclimate, at the climate at the worldwide level. Forests and trees are the green envelope of the earth. Everywhere, when nature was found untouched, it was covered by trees, unless it's too much rocks or a very dry climate. But the tree is the form nature wants to have on Earth as long as it is possible. This is our European forest on southern islands, and this is the Brazilian forest, a big mix of different species according to special ways of making alliances. And tree can be seen as an organ of the forest, but once again, the forest can be seen as an organ of the earth. And this is a very important reflection. In the past, we thought that trees grow well under the tropics because it's wet and warm. It will be warm and even warmer anyway, but if in the tropics it's wet, it is because there are trees growing there. And this knowledge or this reflection is very important and makes us understand how important it is to keep our Amazon in an intact way instead of destroying it at a high rate. So I'm now at the level of quantities or ratios. What does the forest mean for the climate? It's in fact a system which from 100% precipitations makes evapotranspiration at the level of 50 or 70%, making clouds and provoking rains. And part of evapotranspiration makes climatization in the local level. But this is only 50 to 70% of the rainfall. The rest, 30 to 50%, is stored in the soil, not even needed by the trees, but the source of the springs and of the rivers and feeding the groundwater. That's the place in nature where water is stored during difficult times. And if you take the forests away, you have no storage of water. So you have a transformation of the landscape, and the agriculture becomes very, very difficult. You need to water instead of having forest bringing you the water with its biodiversity. So, speaking of trees, of evapotranspiration, this happens at the level of photosynthesis. And the full photosynthesis is even producing new water coming from the hydrolysis of water, and the oxygen of the new water comes from CO2, from carbon dioxide. In the textbooks, CO2 is thought to come from the atmosphere completely, but now we know that a big part, not quantified, comes also from the soil. The soil is a very important source of carbon dioxide. It's much more present, and carbon dioxide is considered as a limiting factor for growth. And we didn't even see that in soils there is much more than in the atmosphere. So we have to reconsider and to find a value for this. But this new water must have very specific properties because it's produced in the leaves, in very tiny cellular systems, and here all the conditions are given to have the appearance of new water. That means newly formed. The water birth happens at this level, also with annual plants, and it's evident that this must be easy water, having such small distances between the membranes. And the assimilation in the leaves, in the chloroplasts, and in the chloroplasts we have the thylakoid systems, and here first at this level we meet with vortices. The structure of thylakoids is a very strange structure, helical structure, the place where sunlight is catched. First meeting with helical structures. Now the trees need very much water. The water is pumped into the crown, not pushed into the crown. It's attraction, it's not exercise of power. And the newly formed sap with sugars is brought down outside of the cambium into the roots or into the stem. You have an acropetal or ascending rose sap. That means water plus minerals. Sometimes it's also sugars. Ascending inside the tree in the sapwood. And you have a basipetal, a descending phloem sap. You have two water movements. One from the earth to the sky and one from the sky to the earth. Very different waters. And modern reflections started already in the 15th, 16th century with Leonardo da Vinci. He already thought about the structure of trees and how is water distributed in trees. It's impressive how he was in advance to his time. And spirality in stem fiber orientation, we can just look at the structure of trees, knowing that the fibers are bringing the water into the crown. It's more the rule that's an extreme case, but what we call spirality in the stem is very often sometimes on the left, sometimes on the right. The conifers have a left-oriented spirality during about 30 years. Once they have their finished dimensions, they change their spirality and spiral against the right side, like this one, as an old one. We have what we call reaction wood, trees which make like a nutation provoked by pressures in the wood, and these nutations must be circular because we have spiral structure in the concentric growth rings. Very strange, and we don't know why this happens sometimes. We have also deformations in the growth rings. Usually they are very regular, like here in the center, but sometimes you have deformations, and the deformations have a pattern which is spirally oriented in one direction, then you have changes. Once again, spirals. And now I was very happy to have this previous presentation, which was mentioning spiral grain in the universe. I have in my presentation spiral grain and wave phenomena and in wood formation. This is a very interesting reference book, a full book concerning waves in trees, in wood formation, anatomy, and spiral grain. What we call spiral grain is the fiber orientation, as I showed before. We have now, concerning the upwards stream of water, in this book, and we also worked on this field, it could be shown that if you inject water at the base of the tree with a dye, with a color, you can observe, after cutting the tree and making slices, how the dye has moved along the axis. And sometimes it's directly axial, but sometimes you have changes, sectorial winding in one direction or the other, interlocked, it changes in one direction and then the other, and sometimes it's winding in on the right side or on the left side, making spirals that you discover in the tree after that, this kind of tests. So again, the tree is standing, but it's a very strong movement inside the tree concerning water upflow. The structure of wood can be considered. That's how in scanning electron microscopy you will find the wood, a transverse section. And here it's a model. It's very long cells called tracheids, and they have an interesting structure, composition, but also geometry. The structure of cell walls is very much spirally oriented, what we call microfibrils of cellulose, which is combined with lignin and hemicellulose. It's not just an amorphous system, it's a woven system with spirals on one direction and in the other direction, like shown here. Inside these tubes, the water is flowing, and the cell wall is always completely saturated with water. It's our problem to get this water out, this bound water in the cell wall, in very microporous system. That's completely easy water, because the cell wall is composed of cellulose, hemicellulose, and lignin, and the inner wall, in the zone of the wall, that's represented here, the inner part is much richer in cellulose and hemicellulose than rich in lignin. Cellulose and hemicellulose are hydrophilic, lignin is hydrophobic. So you see that water flowing inside is in contact with hydrophilic organic material. And now we have something else. It is the structure of the cells here in transverse section. We take out this area, and we can see that the cells have a six-fold geometry, hexagonal symmetry or geometry. Here in the early wood, here in the late wood, we have a honeycomb structure. And here, an interesting question, the phenomenon which is named as a cavity structure effect. which was discovered by Russian scientists like Grebennikov. And I think here is the first question: what does it make for water to flow in such structures? It would have been very easy for the tree to make quadratic systems. Every cell beside another cell, like stones, like bricks, but it's hexagonal. It's a complication which can be considered as very important. And then, before it was conifer trees, with broadleaf trees, we have such vessels, much bigger, up to 200 or 300 microns, a third of a millimeter, still enough or small enough to have this easy water effect. And from one vessel element, its tube, like cylinders, to the next one, the cells join and have only a ring as perforation to go from one to the other. And sometimes there is also a complication with transverse elements in the ring, scalariform perforations, or in tropical species like that. And such geometries are visible. That's in birch, for example, with these transverse scalariform, or like a ladder. You have the water which is filtered through these kind of structures. Imagine what it means for water to flow in such vessels. We have a structure or a configuration which is made for a very dynamic flow. These ripples must have a very important effect on the water dynamization through these vessels. And imagine these vessels in oak trees, many can be in one tube more than 10 meters, one single tube. And that's the kind of fields where we could try to find out what it makes for water. Sometimes species show helical thickenings. Helical thickenings in the inner cell wall. That means not just like in here, it's already with punctuations in the cell wall, but here real helicoidal structures. That's the case for clematis, for old man's beard. And Clematis allayana is the plant we measured at our institute with the highest velocities of water. It's 120 meters per hour in tubes which measure 100 or 200 or 300 microns. If we take the comparison, if it would be 30 centimeter tubes, like in our technologies, this would mean a velocity of 120 kilometers per hour for water flowing through these systems. What do the trees do with this water and these lianas? And if we look at the microstructure, the water will flow helicoidally, but from one ripple to the other, there are also reflections, and with finite element calculations, here it's the schematic passage from one ripple to the other. The question is what happens here in the inter-ripple zone spaces, and it's clear that you have the formation of vortices. And in a vortex, you have theoretically water which will always stay here. Also a question of memory building. Also in rivers where you have vortices, that's potentially places where the water can stay for decades or centuries when the water flows always. And now, is there a cooling effect in the sense of the Kármán vortex street, which shows the effect of cooling on vortex movements? Is it the same like in rivers? Theoretically, a river should be always warmer the longer it is, but it's not the case. In the trees, it's also very important to keep the water cool. If the water gets too warm, it brings the problem of embolism and physiological difficulties. The tree needs cool water. The best way of keeping forest is to have cool forest grounds and warmth in the grounds. Now, spiral forms are omnipresent in the universe. Just a look into geometry. It starts at the germination, at the place of the needles on the shoot. And if we take the quintessence of the conifer, it's the cones. And here we have spirals interlinked in one direction with spirals in the other direction. And here we have the possibility to count how many are turning to the right and how many spirals are turning to the left. Each spiral, each cone element belonging always to two spirals. And right-oriented, we have 13 of them, and left-oriented, 8 of them on this example. But also the needles are, in fact, a metamorphosis of what is visible on the cone. The needles are also oriented in left-sided spirals and on the right, on spirals on the right orientation. Every needle is placed onto crossing spirals. And that's also an explanation for spiral grain in trees, mentioned in this book. It's that the disposition of needles provokes an orientation of the fibers. That means that these spirals influence the water flow, the upwards flow, but also the downwards flow, because the needle are the place where photosynthesis happens, and the sap, the elaborate sap, the phloem sap goes down then with the added sugars, according to this initial geometry. And now Victor Schauberger had an interesting proposition. We always see these spirals turning in one direction and in the other direction. He says the spirals are turning in one direction but coming from up to down, and in the other direction it's an upwards movement. And in fact, in a cone, you have two crossing systems of spirals, downwards spirals crossing upward spirals. And the crossing point of these spirals, where we have the scales of the cone, what is at the basis of the scale? It's the place of the seeds, the place where life emerges, where these spirals are crossing. And I think this is very interesting. So you have an upwards movement, a downwards movement. We have, as shown, spirals in this upwards movement, but we have no idea how it goes down in the phloem zone outside of the cambium. It must also be at the stem level a crossing. We must have something like a downward flow which surrounds the upward flow in this geometry. Now, the spirals visible on the needle, visible on the cones, 8 and 13, these belongs to Fibonacci. The 3 is 0, is 2 and 1. We can start Fibonacci with 0 and 1. I think this is interesting. The 0 as symbol of the universe, of a thing with the periphery, and the 1 of symbol of the earth. And with these two numbers, making the sum, which is more than adding them, the second one has another quality than the first one. The first number 1 is 1, but the second number 1 is 1 plus 0. That must be another quality for my impression. And then you have the start of Fibonacci, every number being the sum of the two previous ones, and the ratio of two following numbers is the famous golden section, phi, 1611803, and very precise, and even more precise is for sunflower, for example. And this, the quintessence of this structure of this Fibonacci series can be found in the apple, in the rose, in the DNA structure. It is the pentagram or the five-branched star, and with this figure, we have, in fact, a concentrate of what phi means. And it's significant for a human being. Back to Leonardo, our body is shaped according to the golden section. from here to the navel, and from then to the top of the head, we have exactly 5 to 1. We have this 5-star system in our body, commonly to the trees, and here is a small stem of poplar, for example, having also in the mark la moelle this 5-shaped star. Now the planetary system, I go outside, has in fact an extremely coherent geometry, a geometry of time. We go from space to time and go back to time with the help of phi. And this is a discovery of a French mathematician, Jean-Marie Souriau, 1989, the same year like Harris with the spiral grain. The golden section and the periods of revolution of the planets, that are very interesting. If you take the two revolution times simplified, the Earth, 365, and Venus, 225, the ratio of these two is very precisely the golden section. And you can build up a Fibonacci series starting with the Earth and Venus, the revolution of these two planets, that's a time scale. You have these values, and you can add, make the full Fibonacci series, and the last number is 30 days, and 30 days is the mean rotation of the sun on itself. The sun is turning on itself in the rate of 30 days. And you have the place of Mercury, instead of 58 days, 85 days, 88 days. You have March, instead of 1 year and 7 months, 1 year and 10 months, it's about. Ceres Pallas, it's a group of fragments of planets, 4 years, 3 months. Here it's 4 years, 7 months. Jupiter, instead of 11 years and 10 months. Saturn, 29 years, 20 and 5 months. It's quite precisely given to the golden section, to Fibonacci series. And Souriau mentions the importance of that. That are time places where there is no resonance. It's places, it's times to turn around the sun, being the Earth, without any too much disturbance by the other planets. They are at a quiet zone. But the Earth is in the medium situation, Venus and all the planets. And now we can go from geocentrism to heliocentrism, and now from heliocentrism to cosmocentrism, taking into account the fact that the sun is traveling in the cosmos with a speed of 70,000 kilometers per hour, and we shouldn't take the sun as a reference, as not moving reference, with the planet always traveling in the ecliptic. All this system is traveling in the cosmos, and the ecliptic movement of the planet, in fact, is a spiral movement going with the sun through the cosmos. And these spiral movements are specific to each planet. And it's exactly the same for the leaf phyllotaxis, knowing that the tree is growing towards the sun. There is heliotropism, and it grows, pushing itself in higher levels. And the leaves are following this movement. So we have a parallelism which is very interesting. And moon, full moon, new moon, is also significant for electricity in trees. We worked on measurements on electrodes, and a researcher who had the chance to accompany its doctor thesis could show that there are gravitational fluctuations of the bioelectric potentials in trees in the same time with gravimetric tides, but also in about the same time like the atmospheric pressure variation. And his measurement, very precise electrotechnic systems could show that the moon periods, like here, the daily tidal periods are visible, the maximum values that are tides in the electro values of the trees. Here we have monthly variations also according to new and full moon, in addition to the daily variations. So we have here water flowing in the tree, electricity in the tree. Is it water generated or is it the inverse? That's a question, but there is this phenomenon. What influence on water properties could be one question. Measurement on trees have shown that at the daily level, circadian level, but also at the monthly scale, the tides represented here have the same, we have the same phenomenon at the level of electrical potentials, with high tides and high currents, and low tides with much slower currents in the trees. And for oak, another demonstration could analyze the subflow, which is also in phase with these tides. So we have tides in trees also in terms of water, not only in terms of electricity. And now I stop with this. The knowledge of ancient cultures, of native nations of North America, for example. Fridtjof Schoen was an ethnologist from Basel who built up a friendship with North American Indians and shamans and chiefs. And Red Cloud told him that there is, in the cottonwood, this tree, Populus deltoides, is their sacred tree. And the leaf is the model for the tipis. And for the moccasins, I need an explanation what is the link, but that's what it told. And he says, inside we find the morning star. And in fact, if we cut the twig, the shoot of the poplar, we find exactly such a star, which is inside the sacred tree of the Lakota or the Sioux Indians. My question is, that's clear, he sees this shape, and he calls that a star. But is the morning star a star? No, it's a planet. And the morning star is a planet, and for Red Cloud, it was not only a planet, it was a star, also for him. How did he have this imagination? Now I come to what Akiko showed us in her presentation. We have the signature spheres and the relative position of Earth and Venus day by day. That's something invisible. That's geometry, that's dancing geometry. The Earth with Venus turning around the sun, and every day it's another position. Here one day, the next day, the Earth blue, Venus green, and that's the dance of the Earth and Venus around the sun. A few days later, we have this geometry, invisible. It's just by making the lines. A few days later it makes this figure, a first, a second involution, then this figure, and then it goes on, makes a threefold involution and a fourfold, and at the end we have this figure. That's the dance of the Earth and Venus around the sun after a few years. I think it needs 5 years to finish this figure. So, thank you for your attention.
Thank you very much. It was a nice presentation. Any questions? And we have to exchange your microphone fast afterwards, because the next speaker will need yours as well. No, you can continue. I will start.
So our next speakers haven't been with us for several years, and now we're glad to welcome them again. They are Beverly Rubik and Harry Jabs with influences on chiral symmetry, breaking down crystallization of salts from aqueous solutions. Please.
Good morning and welcome everyone. It's our pleasure to be back with our water science family. And I'd like to thank Dr. Jerry Pollack and all of the organizers for enabling us to be here and making such a phenomenal conference. So, in fact, many speakers preceding us have already covered some of these basics, so we can glide through them. We've been talking about chirality in several lectures now. And at the level of molecules, there are left and right-handed enantiomers where, for example, a carbon atom is bound to 4 groups. If less than 4, it's not chiral. If there are 4 different groups, then there is the possibility of mirror image compounds called enantiomers. And in ordinary chemistry, in the laboratory or in industry, we get the racemic mixture, 50-50. Of left-handed and right-handed. However, in biosynthesis, it's characterized by perfect chiral symmetry, where biomolecules are either right-handed or left-handed in nature. And we find that there are left-handed amino acids and right-handed sugars. And so most biomolecules made of those substrates end up being also enantiomers of a single chirality. So total chiral purity is considered essential for the origin of life, even though we don't really understand how that happened. That chiral symmetry breaking was a key event in the prebiotic history. Some people believe in it was chance, others determinism. And there's some recent literature showing possible energy differences between enantiomers, although the conventional view is still that there is no energy difference, and the only distinction between left and right-handed enantiomers is the rotation of the plane of polarized light. But some laboratory experiments are demonstrating homochirality and offering additional clues that it's not always that way. So we're interested in what causes chiral symmetry breaking, that is, removal from this 50-50 racemic mixture. And there are some anomalies certainly in nature, in life, but also in vitro, where we observe this non-stochastic behavior of chiral symmetry breaking. And in fact, this may challenge the second law of thermodynamics. The model system that we decided to study actually came to me in a dream, and it's something that I worked on, strange to say, when I was in high school. I did a science fair project on this crystal, sodium chlorate. And so it came to me in a dream, and of course we had to try it. And I'm sure you understand, this group will understand that. The crystallization of sodium chlorate, NaClO3, from aqueous solution. So this is a very simple inorganic salt, and the chlorate ion is not chiral, but the lattice is chiral. It's of the cubic space group P213, and 4 chlorate ions are arranged in a helical structure. And under linearly polarized light, you see, twisting the analyzer in one direction, you see darkness for crystals of the opposite handedness, and then twisting it the other way, the crystals look bright. So they're seen as either bright or dark, depending on the direction of rotation of polarized light. In other words, you get right-handed crystals and left-handed crystals. And you get a mix, normally, just crystallizing the salt in the stochastic way. So what can trigger chiral symmetry breaking, and can we observe this in the laboratory? Well, there is a research literature database on this, and it indicates multiple mechanisms. These are some conditions that have been shown to produce chiral symmetry breaking in sodium chloride crystallization from water. Beta emission, which seems to have a chirality in a right-handed way, spin-polarized particles such as strontium-90 and phosphorus-32, and positron emitters spin in the opposite direction, left-handed, and also yield left-handed crystals. So apparently there's, and maybe you'd like to say some words as a nuclear physicist.
As a nuclear physicist, this really intrigued me because as in nuclear physics, we're being told that anything that happened in the nucleus, the shell doesn't see, and whatever happens on the shell, meaning chemistry, the nucleus doesn't see. But in this case, we have a clear indication that whatever is happening in the nucleus, the beta emitter, which is emitting an electron, or in case of a positron emission, we have in one case a particle, the electron, and in another case the antiparticle, the positron being emitted, and it having an effect on what's happening in chemistry. So that was very intriguing.
Another observation that's been well established in this system is that stirring the aqueous solution of sodium chlorate during the crystallization yields either all right-handed or all left-handed crystals. It doesn't matter which direction you stir, right, in positive clockwise or anti-clockwise, but you end up with all right-handed or left-handed crystals, and the idea is there's a primary crystal then and secondary pieces coming off and via autocatalysis producing all one type of chiral crystal. So our research question is, can we influence chiral symmetry breaking in crystallization using certain stimuli that relate to structured water that involve structuring or energizing the water? And this is an exploratory study. It's our first inquiry into this system. Now, why did I get black? Must have pressed something wrong. Oops. Okay, so our experimental procedures are very simple. We made a solution of sodium chlorate, 5.64 molar, that's practically saturated at 60 degrees centigrade, ultra-filtered, using, in most cases, type 1 laboratory water, which is highly purified. We boiled it to remove any, of course, crystals or nucleation sites that might have chirality, and then cooled it before pipetting 5 milliliters into each glass Pyrex crystallization dish, and the solution was about 5 millimeters deep in each dish. And we had a large number of controls and test dishes that were identical. These were incubated for 24 to 30 hours at ambient temperature between 24 and 26 degrees centigrade under isothermal conditions. In other words, the solutions had cooled to room temperature and were in, I would say, close to equilibrium as they began to form crystals. And we assayed them using polarimetry for the right and left-handed forms. In some cases, photographed them where they appeared unusual. And in numerous experiments, and after examining almost 5,000 crystals, we're going to bring you the results and the statistics. We used polarimetry. Here is a polarizing microscope, which involves a light source, a polarizer. The sample goes in the middle between a polarizer and an analyzer, and you're rotating the analyzer and looking at the direction of rotation. And the direction of rotation is the reported right or left-handed type of crystal. And in many cases, I could just do this outside of the microscope. The crystals are so very large, I could simply do it over a light box using handheld polarizers and analyzers. So here are just sample photos of how this looks. Again, light is turned to the left in this crystal, and when the analyzer is turned right, it's dark. And you just see the opposite images, and you count the number of bright crystals when you turn left and the number of bright crystals when you turn right, and that is what's reported numerically in this study. So we looked for the influence of various stimuli for the effects on crystallization in this system. There are 6 things we studied. One was vivo structured water, and we have in our audience the inventor of this, Lee Lawrenson, and also Glenn Ryan, who's done studies on it. We looked also at a dynamic magnetic field, an acoustic field of 432 hertz, a product out of Hong Kong known as Biodisc 3, which is a purported water structurizer, Purple Plate, which is a purported subtle energy device connected with Nikola Tesla, and a pyramidal structure, looking for the influences of these devices on crystallization and chirality symmetry breaking. So here is the first stimulus, structured water. In this case, we used as a control boiled Vivo water to remove all structuring. As I was told by the inventor, that heat will remove the structuring. And in the case of producing the crystals, we only took it up to 30 centigrade so we would not disrupt the structuring. This water is apparently treated by strong magnetic fields and light treatment to form a stable structured water, and is commercially available and patented in the United States. There's the patent number. And there's been a controlled study showing improved hydration of the internal body and the skin by Glenn Ryan and colleagues. And the results with Vivo structured water are as follows. We actually did not find a difference between left and right-handed crystals in percentage. Left was slightly higher, and I can't read the numbers here. Sorry, I have to go over. So right-handed crystals, 42.3% under Vivo water, and 57.7% left-handed. Control is 45.9% right-handed and 54.1% left-handed. But those differences are insignificant. So it's as if we have just the random case of no chiral symmetry breaking. And also the crystals appear the same in both conditions. No unusual difference in crystal habit, shape, or size. The second stimulus that we utilized was a dynamic magnetic field. In fact, it was also a commercial product. I was intrigued with the Lightstream coil system with the water restructuring program of David Sarita in Canada. And we used a particular audio file, sounds that then get converted and amplified, 2 volts root mean squared, powering the coil. The coil is a very complex thing, as you can see here. And previously we did some studies on this coil and found that it was a very dynamic magnetic field, actually very non-uniform as well over time. But people meditate with this coil and experience epiphanies. And he does sell this program, water restructuring audio file. So we thought we would take a look at this. The dishes with sodium chloride crystal solutions were placed on top of the coil, and the signal was broadcast continuously for 24 to 30 hours. And the results with the dynamic magnetic field with this restructuring water program, the crystals appeared about the same in both conditions, although in this case we got some apparent chiral symmetry breaking. Right-handed crystals amounted to 57.3% under the magnetic field, left-handed 42.7% under the magnetic field, and the controls 44% right-handed and 56% left-handed. Those differences were, however, not statistically significant by paired t-test. The p-value is 0.20. The third stimulus that we tried was an acoustic field of 432 hertz sine wave, and we did this with a digital tone generator. It's interesting because 440 hertz is the modern reference frequency for tuning musical instruments, but there's a growing literature showing that in the past, instruments were tuned to 432, and there's been some experiments done where people are exposed to music tuned to 432 instead of 440 now, and they get a reduced heart rate, lowered blood pressure, and a greater sense of relaxation. So there may be some biological effects. So it's an interesting frequency, and we decided to use it. And we used an NCH tone generator software with 3 volts root mean square signal using Altec speakers, as shown in this setup. So there are the test beakers, and the 2 speakers are on either side. And the audio signal was played at a 55 decibels audio, which is like a low-level conversation in volume, played continuously for 24 to 30 hours until crystals form and could be analyzed. In some previous studies, I used the gas discharge visualization camera, a high voltage form of electrophotography similar to Kirlian photography, to look at water initially and water treated by 432 hertz audio sine waves, and found a significant difference in the corona discharge. So apparently the water is more energized by this frequency. So the results with the 432 hertz acoustic stimulus showed a difference that was significant. Also in the shape and form of the crystals. On the left here are very large crystals, which we tended to see with 432 hertz stimulation during crystallization, compared to controls. You can see they're more than twice as large. And the differences here with the 432 hertz signal, we got 67% right-handed crystals and 33% left-handed crystals. And that was significant by paired t-tests at p equals 0.049, just barely significant. And controls were within the 50-50%. Now, we're going to take a look here at some subtle energy stimuli that we utilize, and I'll turn it over to Harry to say some words about that. We've done a lot of research on subtle energy in our lab.
At this point, we would like to segue a little bit into a project that we did previously, and here you see a prototype of a, what we call a sensor suite. It's a bunch of electronics, but I want to direct your attention to this thermoscan here. In there is one specific and very special detector that we developed that is inside a completely shielded enclosure, temperature stable to 0.1 degrees centigrade, and it's again shielded against all conventional fields. And yet, when we bring in healers and ask the healer to do a healing on them, then the computer that records a data point once every second and shows it up here is indeed responding. So we were very intrigued that we achieved a coupling between subtle energies and a physical object, in this case a sensor. We brought this up because this is important, because it may shed some light onto the fundamental mechanism between the subtle energies that we as humans all experience and the material world that seem to be elusive, but I think we may have a coupling here between the two. Oh, and this is important because projecting to the project here with the crystals, imagine this. When you have the crystal just about to form from at the aqueous air interface, and it does so in a field of subtle energies of certain type, then it may be extremely sensitive to either start crystallizing in a left or in a right chirality. Once that starts to form, then the rest of the crystal grows essentially epitaxially, and we can then see it.
So the first subtle energy, purported subtle energy device that we tested with the crystallization system, the Amaskua Biodisc 3, this is a purported water structurizer that's in the form of a slightly concave disc, and it's a product out of Hong Kong based on subtle energy. It's a clear glass disc about 9 centimeters in diameter and about 1 centimeter thick, composed of treated granular crystals of a proprietary technology. It does not influence the polarized light, so it's not influencing it in that way. There are also geometrical designs on the disc. There are some concentric circles, some dots and arrows and parallel lines that relate to biogeometry, some forms that were studied by Ibrahim Karim, who's an expert on ancient Egyptian geomancy and has published on that. So some of these designs were taken from ancient Egypt literature, and they purportedly also affect water. Ordinary light passing through this disk is said to be more coherent, although we didn't study that. And there's a recent study that was just done by Dr. Konstantin Korotkov, who's usually at this conference, but not this year, showing that health benefits of drinking water treated by this disc that was just published in this journal this year. So many benefits from heart rate variability to biofield enhancement to hydration improvement. So there apparently is some effect physiologically. And we studied it with the crystals. And this device produced the strongest effect on chiral symmetry breaking. And also, we found, much to my amazement, the formation of hexagonal crystals in a cubic crystal system. Never seen that before. They weren't all hexagonal, but there were a fair number of them, and they were large as well. Large and rather clear with less inclusions, and that suggests a reduced entropy when you have larger crystals, fewer larger crystals in a chemical system. So the chiral breaking here was significant. With the biodisc, we got 81% right-handed crystals, 19% left-handed, and the controls were, as usual, close to 50-50, 49.5% right-handed and 50.5% left-handed. That was significant at P equals 0.034. The next subtle energy technology that we chose was purple plate. And this has quite a history. It goes back to the 1970s and is well known and not necessarily well studied, but there's a lot of lore about this. There was a man, Ralph Bergstresser, who apparently spent some of the last days with Nikola Tesla, who went on to commercialize this technology and attributes it to Nikola Tesla, that it was some aluminum plate treated by high energy methods of Tesla that are not disclosed to force the material into a more homogeneous structure, as it said. It's also anodized purple. And it's believed that this plate may transfer information to the surrounding media to restructure it. So the results with purple plate technology were also statistically significant in breaking chiral symmetry. We found that right-handed crystals with purple plate, 64.9%, and left-handed crystals, 35.1%, compared to almost 50% in the controls. This was highly significant at P equals 0.003 by t-tests. And once again, as with the others where we found chiral symmetry breaking, we found larger, clearer, less inclusions in the crystals, also suggesting reduced entropy. The last system that we'll describe here is a pyramidal structure, and we had previously done some studies on pyramids. I'll let Harry speak about it.
The pyramid structure, we came about because I once got sick. Actually, I injured myself in my back, and I got sciatica. It was extremely painful, and I didn't want to undergo surgery. So I remembered a book from 20 years ago where pyramidal structures could heal. So I went to the local hardware store, got some wood, built myself a pyramid, and slept under it. And within 3 weeks, I was cured. And I was so intrigued by it that a neighbor actually also cured his dog that was about to die and that still lived for another year. And then with Beverly, we actually said, okay, we got to study this scientifically. And we actually did a bean sprouting experiment. And lo and behold, we found that beans sprouted under a pyramid generate about 20% more biomass. That was really substantial.
I should point out that our pyramid was not in the sacred geometry form. It was an equilateral triangle symmetry, so it did not encompass phi geometry. But it did have a compass right here, and we oriented the side to magnetic north, as shown here. This was for the plant experiment, but for the crystal experiment, this was also oriented so that this was pointing toward north-south. And there are the crystal dishes. According to Feng Shui, which is the ancient art of placement from China, in such structures with peaks, yin is drawn upward and out and yang remains. So there is a lore about such structures of domes and pyramids. The results with this pyramidal structure, which was composed of just the wooden outline, were insignificant in terms of chiral symmetry breaking. we found right-handed crystals under the pyramid 51.4%, left-handed crystals 48.6%, and the controls were also close to 50%. So the the t-test showed insignificance in chiral symmetry breaking, p equal 0.312. And there was no apparent difference in crystal morphology or size. So this is a summary slide. Just to show you, we did literally almost 5,000 crystals. And I'm quite confident that we really did see chiral symmetry breaking in the cases where we showed. We could improve these statistics and get even smaller p-values doing more and more experiments. But at some point, you'd rather go on to another condition than continue to improve your statistics. So the numbers of crystals here, percent left, standard error of the mean, percent right, standard error of the mean on the right, and the p-value by paired t-test, and something called the enantiomeric excess, which would have a value of 0 in the case of a racemic mixture of right and left, and a value of 1 if we had perfect chiral symmetry breaking. We did not get that, as you can see. We only got partial chiral symmetry breaking. But it's very intriguing that it was always toward the more right-handed crystals. Never did we see more left-handed crystals. So here's a visual summary of our results. And again, the strongest result was with the BioDis 3, a passive subtle energy type device that yielded 81% right, 19% left. And the others, the 3 significant ones are here and the insignificant ones elsewhere. So reconciling these anomalies, some would say that there would be chiral impurities that could act as seeds. Maybe a little dandruff fell in in the crystal dishes. But then you would say, well, then it should occur equally in the controls as the treated. And it didn't. So I think we can rule that out. We could talk about torsion physics. Possibly this is involved. It's interesting to note that watching these crystals from an isothermal system, the crystallization begins at the air-water interface, which of course is very rich, that special interface. And when the crystal weight exceeds surface tension, we watch the crystal fall to the bottom. And then the crystal continues to grow. So the chirality is determined at that interface for this type of system. And so the water structure at the air-water interface may play a role in initiating crystallization and chiral symmetry breaking. However,
again, this is so crucial because it shows that apparently unconventional fields seem to have an effect on the process of seeding the crystallization. Once the crystal is seeded, then the rest is just epitaxy as we know it. But this critical moment, on a microscopic scale, you can envision it being a localized chaotic system, and then you have an influence that has a tendency to very sensitively and delicately influence the system into going either one direction or the other. And from the study that Beverly did, you can see that under certain circumstances, you get a statistically significant left or a statistically significant right start of that process.
But this.
And the microscopic examination of crystal formation using colloidal microsphere did not reveal any exclusion zones. Since we did previously an experiment with Naphion and exclusion zone under the microscope, so we were familiar with that process. We did a similar process and we looked to see if there was any exclusion zone, and we looked very, very carefully, even with the focus depth, seeing if there was a three-dimensional structure, and there was none. We can clearly say that at least as it pertains to our crystal formation, there was no easy layer formation that we could tell.
And we used carboxylated polystyrene microspheres, 1 micron, as well as 2 micron silicon dioxide microspheres, examined the air-water interface of a saturated solution just beginning to crystallize, and watching the various levels, and then watching crystal growth as well. And we did not see any exclusion zones, but we're dealing with 5.64 molar salt. So it probably may not involve exclusion zones as we presently understand them.
In fact, that high concentration may actually be an indication that an exclusion zone is prevented from occurring when the salt concentration is so high.
But it doesn't mean that there isn't something special happening at the air-water interface. And now.
Okay. And now we looked at, are there any chiral forces in nature or any chiral structures that we can see? And yes, of course. We have our spiral galaxies that have a directionality. The planet trajectories that in earlier talks today we even saw that, that the planets make actually a screw helix as they revolve around the sun, and the sun orbits the center of the galaxy. Then we have common quartz crystals which have left and right direction. Water never naturally flows in straight lines. It always flows in and meanders, and also has vortices when it becomes turbulent. And we have cosmic asymmetries at all levels of order, from very small to very large. And the scientific foundations to it, we can ask, what are these? And there in nature you can, for example, see a shell that has a spiral, or also the DNA, as we know, has a spiral.
So at all levels of order in nature, we find helices seem to be shaping, and of course we've heard from Jim Oshman and the previous speakers, there's something perhaps about a vortical nature, physical nature of space itself. And Harry and I have explored this as the idea of the neo-ether, reviewing the scientific, shall we say, expulsion of ether from science that began with Maxwell, and earlier going really to Aristotle, the concept of an ether, which goes back to ancient times. And we wrote a paper on that, and you can read it, it's on our website, onto a possible neo-ether that might help explain a lot of these things today.
And interestingly enough, in order to find out what is actually going on here, we actually went back and read the original papers written by James Clerk Maxwell between 1861 and 1865. And we found, to our quite amazement, that his theory of electromagnetism was based on the fluid dynamic model of tiny atomic vortices. So there we have the spiral concept again.
So in conclusion, aqueous solutions are complex, open, non-equilibrium systems characterized by subtle structural and informational states, much as water is. Subtle external stimuli may impact solute crystallization. And we found that 3 external stimuli altogether out of the 6 produce alterations in crystal size, in some cases shape, and chiral symmetry breaking. The Biodis 3 water structurizer, a simple coaster, 432 hertz audio sine wave, and purple plate technology. But we only observed partial chiral symmetry breaking, and only to make more right-handed crystals and never more left-handed crystals, which we can't really explain unless there is some preferential vortexing going on in the water or in space that may be shaping this. Also observing larger, more perfect crystals with less lattice imperfections. So we speculate that the chirality of crystal nucleation sites in sodium chlorate aqueous are impacted by perhaps a neo-ether flows that couple to subtle energy stimuli. And our last slide here, there are potential industrial applications of being able to direct chiral symmetry breaking. For example, the synthesis of drugs and agrochemicals, you get racemic mixtures, and they can be quite toxic. Sometimes one form is the bioactive form, and the other form is dreadful. The example that I remember historically back in the 1960s, the drug thalidomide, also known as Contergan in Germany, The left-handed form was desirable. It has biological effects, but it was the racemic mixture that was given to pregnant women for anxiety and nausea during their pregnancies, and it produced heinous birth defects, such as shown here, the loss of limbs and grotesque results. And so we need new methods to separate enantiomers in the chemical industry. And it's quite possible that external stimuli, such as 432 Hertz and water structurizers, may work in terms of helping separate and concentrate the desired enantiomer for human use. So that's it.
Thank you so much. That was so interesting. And any questions? Yes.
Thank you very much. I'm extremely excited as a chemist to see these results. Now, I have two questions actually. First, whether you also analyzed the size of the crystals, because going for the diameter on the photograph or even the three-dimensional volume, you might find much larger effects of the ratios of R and L, how the molecules are accommodated in either form. Although you are correct to analyze just the number of seeds and not the volume, which would be exaggerating in the result. However, it still gives you some information about the age of the crystal, whether it started to grow early on in the process or later on to produce a tiny amount of sprinkle. That's the first question. And the second, how did you exclude that your consciousness, your expectation of one device working better than the other might have influenced these data?
Okay, the first question, I actually did not expect differences in crystal sizes or morphology. So it was just sort of a happenstance I decided to photograph them when they were anomalous. But again, this was a preliminary or exploratory study, the first one. So it wasn't done to really look at all the differences. The main question was the chirality symmetry breaking. But in the future, we could certainly analyze size more precisely and volume of crystal, et cetera, and follow growth rate. There are just so many more things that can be done. And secondly, we didn't rule out the, shall we say, the influence of conscious intent, but that's always present in science. We did not do this experiment in a blinded nature. Again, it was exploratory. And future studies could do that, but you still can't rule out that the experimenter doesn't have a non-local influence on the results.
By the way, your second question is actually very, very profound. And we found that in our year-long experience with the subtle energy detector. We tried to reproduce the responses that healers had on the effect. And we could not reproduce things as we would have wished. We could only reproduce in kind. And we then later understood it, okay, because this is also an effect that is dependent on time and space, and you can never step into the same river twice. Or better yet, you can never have a second first kiss. You can have it only in kind with somebody else.
Thank you. Thank you very much. A brilliant talk. That is the talk I shall be taking home with me more than any of the other talks, and the others were brilliant as well. People who know me well will know what I'm going to say next, which is that one of the other sources of chirality symmetry breaking in the universe are neutrinos, because there are only left-handed neutrinos. And I was interested that that was not on your list of possible explanations for what you'd found. And I would want to add that to the list, and there are additional experiments then with that hypothesis that I feel you could consider doing, like taking your brilliant protocol that you've now developed to Neutrino Alley, where you've got a much higher neutrino flux, to see whether that makes a difference to the results that you're now quite repeatably getting.
Well, thank you for that suggestion. I hope we can follow up with that. That's interesting. Certainly in our experiments, the neutrino flux did not vary between the controls and the experiments, so we're not speculating on that, but that's very interesting. Thank you.
Over here, next question. I fascinating talk. I really enjoyed it, and I think it opens up a whole new field of opportunity for evaluating various substances that are being promoted as being biologically active. I think it's very exciting work in that respect, and thank you for that. I just had a comment about the chlorate and the lack of any visible easy water. There's a Hofmeister series characteristic of different anions and cations, and the series, sulfate and phosphate are more cosmotropic, and then nitrate and chlorate are more chaotropic. Chlorate is even more chaotropic than nitrate, and chaotropes destructure water. So it's quite possible that the reason why you didn't see any structured water is because the chlorate destructures water.
So we could use different crystal systems with more organizing solutes. That might yield different results. Well, I opened this up.
It would
I
be
think
fascinating
it's
if you
worthwhile.
can. If you can come up with another crystal that is a cosmotrope, it would be very interesting to repeat these experiments. Very exciting work.
The only problem is there's few crystals that have right and left-handed forms.
I know. I was
sodium
suspecting
bromate,
that.
sodium chlorate, and find me some others. I can't think of any. So we might go then to organic chemicals that crystallize either in right or left-handed forms.
Right. Thank you. Yeah.
Thank you.
Presentation. Can you hear me? I very much enjoyed your presentation. I've been looking forward to it, the whole conference actually. So it was very insightful for me, your protocols and methods. Was there anything done in terms of temperature and humidity tracking during those experimental processes?
No, there wasn't. We live in the San Francisco Bay where temperature is pretty constant in our laboratory. We don't even have air conditioning. But we could monitor that. We certainly have thermistors and humidity probes running regularly on this sensor suite that Harry showed you.
Yes, our sensor suite has about half a dozen environmental sensors, including a muon detector. So if the sun is doing something and there's something happening in the upper atmosphere and we get more of a muon shower, we will be able to see that. And we did that on purpose because we found that during our experiments with healers, some days were good days and some days were not so good days, and it was not obvious why that was. So we figured, okay, we need to at least have a detector that shows us a little bit about space weather. So we're even sensitive to space weather. And also, by the way, we have a very sensitive flux gate magnetometer at our sensor suite. So if the Earth magnetic field changes ever so slightly, we will see that. So we have not a direct, but an indirect confirmation of whether anything happened in the environment, even beyond temperature and humidity.
Have you considered doing your experiment south of Quito, in the southern hemisphere? Do you think that would make a huge difference or not?
The Coriolis force effect. It's quite possible. We have colleagues in Brazil, but I don't know that they're set up to do this. But I think it would be worthwhile if anybody's south of the equator.
If you've been to Quito and seen the magical line that runs through a part of Quito, where you can step one side of the line on the other side, and the spiral of the water is different, I wonder whether that would change your experiment.
Well, actually, Victor, I have a hunch, and this is just a hunch. That yes, while it is obvious because of the Coriolis force that certain things on the northern hemisphere may be the opposite on the southern hemisphere. But when it comes to subtle energies, see, the Coriolis force is not necessarily a subtle energy. There's probably a component to it, but first and foremost, it's physical. But our work with the subtle energy sensor suite has shown us, or given us at least a hint, that we have to really think bigger, much, much bigger. So first of all, we're sitting on the face of the Earth, which rotates at high speed. Then the Earth rotates about the sun. Then the sun rotates about the center of the galaxy. Then our galaxy rotates within the local galaxy cluster about the center. And then you can even step further back and say, oh my God, all the clusters are rotating about something. So from that point of view alone, you can see that it is very, very difficult to affix something to a certain absolute reference point. And of course, there I don't tell you anything new. Einstein wrecked his head about those things years ago.
Yes, hello. You were mentioning spirals, but spirals are not chiral. They are identical to the mirror image can be superimposed if it's turned upside down. So why do you mention spirals when they are not chiral?
Well, for example, I guess it relates to your perspective, of course.
No, it's well mathematically defined.
Sorry, could you repeat that? I didn't catch it.
Spirals are not chiral. Their mirror image are identical to if you turn it upside down. So spirals are not chiral.
That's true if they are flat, but not
Yeah,
if
they are
have
flat.
a uniaxial direction.
Yeah, then they are helices.
Yes, I
So
think we're
then
talking about helices because in cosmology, you know, it's not solar system 1.0 where the planets are in a plane moving in circles. The sun is moving, circling the center of the galaxy, and the planets are moving helically.
Yeah, then you should be more specific about the terms.
We showed that in our slide, by the way, the new solar system 2.0 of the helical trajectory of planets, and so did the last speaker.
Thank you for pointing that out. It means also that we have to be very precise with our language, because we're here in an area where language is really key. We have to really first define what we mean by certain words. So thank you.
May I? Beverly, you were working always, of course, under the influence of natural geomagnetic field. What if to try to make experiments with the shield using, for example, permalloy screen and so on with this this disc? You can put it inside and try to see if it works or not if you shield it from the environment, geomagnetic field. That's one question. And another, what if to treat water before dissolution of the salt in this water and see if it is water which, not solution, very strong solution, is the receptor, but what is the receptor, and then if it keeps memory of treatment.
Well, because I used Vivo water, and which was structured and with this disc. Okay. I could try that, and certainly I will. These experiments are very easy and quick to do. And I like the idea of trying to shield it with mu metal or other screens.
Thank you for that,
Thank you for
Vladimir.
these suggestions. We will follow up.
If we would do a series of experiments like you suggested, we would definitely know more afterwards.
And Beverly, thank you for your study. I just wanted to mention when we're manufacturing Vivo, it's subject to ionic shock. So when we make an isotonic solution, it takes 9 hours of titration to bring it up to speed without disrupting the structuring. So that might be something to look at in the future.
Thank you.
Thank you so much.
Thank you.
And before going on a break, there's a short message that we need to talk about. And some of you may know that the Department of Bioengineering in the University of Washington in Seattle is considering the idea to decrease the laboratory of Gerald Pollack, where he works and teaches his students, in size down to 20% and take some of their rooms away from them. So there's something that we actually can do, and we have written a letter. And those of you who think that Professor Pollack should retain his spaces and resources the way it is so now, can sign this letter, put name, surname, position, and place where you're from, and then just do it. And you can all read this letter. We'll pass this on the tables, and everyone will have a chance to read it. Thank you.
Couple of more announcements. So first of all, checkout time from the hotel is 11 a.m. So if you're not staying till tomorrow, you can either go check out now or arrange, late checkout. Another thing is we have a box for your name tags over there. You can keep it if you want. You don't have to give it back, but if you don't need it, I think it's better for environment to use them.
So we will now announce second announcement that these forms are here and that you should sign them. Yeah. Okay. We will now okay, good. I must take care of Did you get coffee? Did you get something to eat?
I had tea, but the rest of the food was done. Only bananas.
Hopefully organic. After the green banana. Oh, so Matthew Shitakos.
Yes, and I envision it in some kind of a pop-up flavor.
Dear audience, we have to proceed a little bit, otherwise we are running in a very late lunch and ending. So I would like to announce Matthew Shidakos, and his presentation has a title, Using Supercooled Water to Detect Radiation. Matthew, for you.
Thank you. Is my mic on? Okay. All right, so thanks everyone. It's great to be here. I'm going to be telling you a little bit about my work at the University at Albany using a form of water called supercooled water. So you can read about our results here, the snowball chamber neutron-induced nucleation in supercooled water. And although I'm a physicist and focusing on the physics, there are interdisciplinary applications with chemistry, meteorology, and biology. And there are different experiments I work on and different things I look at. So today I'm sort of wearing my research and development hat to sort of come up with a new idea. So I'm working with several other universities and Brookhaven National Laboratory in the United States, in New York State. So we presented at many conferences now already and workshops, and my students have as well, around the country, in the US and around the world. So first I'm going to start with what is supercooling. So when a liquid is cooled below its normal freezing point but doesn't freeze, this is what's known as supercooling. It's not the same as adding impurities to water to change the freezing point, like salting your sidewalk in the wintertime. That's not what we're talking about here. This is the creation of a metastable state that's in between a stable and unstable thermodynamically, and requires high water purity and a clean, smooth container. So this probably, as many of you know and love already, is the phase diagram of water. And we're talking about moving between, going below the freezing point by lowering the temperature adiabatically and entering the phase space where the water should be solid but remains liquid. So there's an analogous process that's actually maybe more famous, the opposite, which is superheating. And that's when you heat a liquid like water above the boiling point, but it doesn't boil because the container walls are too smooth and the water is too pure. This can happen in the microwave, for instance. But I'm talking about supercooling, the opposite direction. So as a function of time, pure water will not stop it to freeze at 0 degrees Celsius, but will keep cooling below that, and this is the regime of supercooled water. And when the water does freeze, though, the entropy of the water is reduced through the formation of the hexagonal structures in snow or ice, and this causes the temperature to actually of the environment to rise to 0 and of the water to rise to 0 degrees Celsius. So there's a spike in temperature actually, so counterintuitively something freezing actually makes things warmer. And so once the nucleation starts, it can be caused by different kinds of disturbances. The process snowballs, it's highly exothermic. And smaller samples are easier to cool. The minimum temperature you can achieve depends on the volume of your water. And this is the only unexplored phase transition in particle physics where the cloud chamber and the bubble chamber has many decades of discoveries behind them using supersaturation and superheating respectively. But this is with a supercooling. So if you're familiar with the Netflix show Stranger Things, it's turning the concept of superheating in the bubble chamber upside down with supercooling. So the challenge is using supercooled water, which has been done before to detect radiation, but only betas and gammas, and we're looking at different types of particles, specifically neutrons. You want to get as cold as possible without any unwanted nucleation spontaneously. So colder should be better because it should mean a lower energy threshold so that it's easier to detect particles. But you have to avoid things like dust, which creates what's called heterogeneous or heterogeneous nucleation, and avoid what's also known as the homogeneous nucleation limit when the water gets so cold that it will spontaneously still freeze. So you have to also find the ideal rate of cooling. Too slow means your detector has a very low lifetime and you have more opportunities for unwanted nucleation, which is the phase transition into freezing. And too fast, though, means you can induce a thermal lag or a thermal gradient in your detector. So I just adopted a let's try it and see approach without a model for how this would work. So superheated water, as I mentioned earlier, is much better understood, has been used for decades. But supercooled water has not, while has been studied for centuries, in fact, I believe discovered by French chemists in the 18th century, has not been used in the particular application we're looking for, which is the detection of radiation, specifically neutrons, to see if an incoming particle can trigger supercooled water to freeze. So we wanted to see if it's reproducible, statistically significant, had control tests, of course, with no radiation, and used other forms of bias mitigation techniques. We had to be ready to fail that maybe this idea wouldn't work. But as I show you, it actually did work spectacularly beyond our wildest hopes and dreams. So here's our prototype detector setup. We had about 20 grams of ultra-purified water contained in a smooth, cleaned, fused quartz vessel. So when I say purified, I mean beyond anything you've seen, I think, at any of the sponsors or posters here at this conference, by several orders of magnitude. So we're not talking 5 microns or 1 micron. The final filter through which we pass the water is 20 nanometers. So that means there are no particles of dust larger than 20 nanometers in the water. And we've recently upgraded our setup from 20 nanometers to 5 nanometers, which is the cutting edge in nanofiltration technology in the world. We didn't invent it, it's commercial, so we buy it from a Swiss company actually called Novamem that produces these membranes for separation. So even though a water molecule is still is much smaller than 20 or even 5 nanometers, that's still several water molecules across, the surface tension of liquid water prevents it from passing through. So we have to boil the water and distill it through as gas. And we have thermometers, thermocouples in 3 places at the middle, bottom, and top of our vessel in order to record the exothermal spikes. So before what you saw as a cartoon, here is real data with liquid water below minus 20 C and still at close to atmospheric pressure. And then when the freeze occurs of the supercooled water, you see the spike in temperature, which occurs on the time scale of only a couple seconds. So we used a borescope camera, since we have just a very small chiller that was used to cool the water, so we could only shove this one borescope camera in to be able to take images. So as a result of having only one camera, we did not have three-dimensional position information. We hope to do that in the future, but instead just focused on counting the number of snowballs that are observed. We also had a coincidence counter under the vessel. It's not in the image, but a small piece of plastic scintillator which produces light when radiation hits it and records it with something called a silicon photomultiplier. And so one of the things we looked for was coincidence between a flash of light in the detector beneath the vessel housing the water with the moment of freezing. Here are some electron microscope images of the 20 nanometer NovaMem filter we used. So the other remarkable thing about this filtration technology for water is that these are not straight holes like a normal filter. They have this patented technology where they produce filters that have cavernous holes that are not straight. And so that just makes it even harder for dust, for impurities to get in and contaminate the water. They get lost in the caves through as the steam is passing through. So that's how we're able to achieve this incredible level of water purity on the nanometer scale. So we MacGyvered things together a little bit in our lab, as I said, using simple cameras and an ancient laptop. And we achieved, as I mentioned earlier, minus 20 and lower, which is actually nowhere near the world record, which is minus 40 for supercooled water. And the theoretical minimum is negative 70, which we believe is happening in the upper atmosphere. But that was not the purpose of our study. The purpose of our study was not to try to get the coldest possible liquid water. That's already been done. The purpose was to see when water is supercooled, can it be used as a radiation detector? And does it have better or different properties than existing technologies? So we had very close to atmospheric pressure, just a 50% partial vacuum, but not of air, of the leftover water vapor that had been pressurized to be pushed through the membrane as steam. And we have in our proof of concept prototype a very, very long cycle time. So this is one of the reasons why for decades, why superheated liquids were used, not supercooled liquids, to detect radiation, because when something's boiling, it's very easy to stop it by changing the pressure. But when something's freezing, it's incredibly challenging thermodynamically and practically to stop something from freezing. So we would have to let our whole 20 milliliter volume freeze and patiently then melt it. And so we unfortunately had a very long cycle, which meant it was very difficult, and it took many months and years to take data with sufficient statistics to be able to make any quantitative conclusions. So we did multiple run conditions with different types of calibration. Our control is no radioactive source, of course, just ambient radiation that's naturally all around us all the time. And then we use different kinds of neutron sources, americium, beryllium, and californium-252, both with and without lead shielding. And the purpose of the lead shielding is to block the gammas, because these neutron sources, unfortunately, are mixed. They produce both neutrons and gammas, and we want to know what type of radiation produces freezing, not just a binary yes or no. So we also did a study with a pure gamma source, cesium-137. The other purpose of the lead shielding is to stop gamma rays from interfering with the operation of our thermometers and possibly skewing the results. So that's why we have that bifurcation. So here are some example events. So over here in the left is, you can see the remarkable images you get because pure water is going to appear black. It's not going to scatter light very much. We use LEDs to light our quartz vessel. And when snow forms, though, as you may know, snow has incredibly high reflectivity, one of the highest values of what's called albedo of any substance known to humanity. And so you can see even at one, you can see a couple pixels light up as snow begins to form. And what we found is that sometimes we get double or even triple events, which to the best of our knowledge, searching the literature in condensed matter and chemistry, we have not found any other example. So we still think that this is a world first, which is multiple formation of snowballs in supercooled water at the same time. And what we think is happening here is that you're witnessing neutrons actually scattering in real time, since water, which is very hydrogen rich, obviously, is really good at scattering neutrons. So you can actually watch these, microscopic subatomic particles, neutrons, you can actually watch them scatter in real time. And since they're moving at a substantial fraction of a speed of light because of the energy at which the neutrons are produced, typically you're going to see something within the same frame or within one frame apart in the camera. So when you see a third or fourth snowball form later on, we think that's most likely due to another neutron, because the rest of the water is still super cooled while part of it is still forming snow. There's still liquid water in a different part of the chamber over here. So this is one of our really good results here. But before we even did our advanced work with a commercial professional chiller heater, which actually I just realized is from a German company, Huber, which makes the best, apparently, heaters, thermoregulation chambers in the world. We also, before we even did that, we had much simpler tests in my freezer in my office. So we started out very, very simple. And so here, I don't know if this, the sound will work. We will soon find out. Yeah. So I'm going to fast forward to the good part. So we had some water we put in my freezer, and we put some oil on top because the oil blocks, it prevents the water-air surface, which can trigger nucleation of the supercooled water. And so we're lowering a temperature probe now into the water. So this is one of our initial tests where, we knew it was going to work. As I said, supercooled water has been studied for decades, centuries. But we wanted, we started to have some fun with our initial result and just wanted to see how easily we could supercool water just in a regular freezer, nothing special. The only thing special, so this isn't the highly purified water or anything like that. The only thing special is oil on top, so that you have the oil forms a virtual cap on top of the water. And now we lowered the temperature probe into the water, so there's the oil on top, here's the water at the bottom of our jar, and we wiggle the thermometer around and we get a reading of -8 degrees. Again, Celsius, as scientists, I always beat Fahrenheit out of my students even. So, and there you see it froze because when we wiggle the thermometer around and disturb it, we get this formation of snow, which is not ice. It's more a disordered crystal than your typical ice. We also have another video here that one of my students put a little music to. This is one of our later, you can see the formation there in slow motion of the snow. And you can see that there was some structure in there. It did not have perfect spherical symmetry. So some of our events appear to have a perfect spherical symmetry in the snow, and others have some sort of asymmetry or asphericity to them. So that's all pictures, but what are our important quantitative results? So our first important quantitative result is that neutrons do indeed cause the water to be supercooled for a significantly shorter period of time, and gammas are statistically indistinguishable from control. So the effect is enhanced with lead shielding. One thing you have to remember is that unlike in science fiction, lead is not the magical shield for all radiation. It makes neutrons worse. Lead is for blocking gammas. If you want to block neutrons, you need water or wax, something hydrogen rich. And so the effect being enhanced with lead shielding actually makes sense because lead the lead blocks gammas but produces a greater number of neutrons with secondary production in the lead. And the effect was also bigger with a stronger source. So our californium source, which produces 3,000 neutrons per second compared to 200 neutrons per second, had a significantly larger effect. So as far as we can tell, I still have not gotten the angry email that this was done in Russia in the 1970s, although that does happen, you know, to many, oftentimes. We conclude that this is the world's first observation that neutrons can freeze water, freeze supercooled water, that is. So to make sure we weren't fooling ourselves and biasing the result, we alternated the source and background runs to make sure this is not some drifting effect from the chiller. And we also checked room temperature as a systematic. The room temperature had absolutely no discernible effect on the result. And we also checked the temperature at which the water froze, and the temperature matches. So when the water freezes earlier, that's because it also freezes at a higher temperature because the chiller is ramping down at a fixed rate. So here are some of our other results, breaking it down by source. So we also looked at, we didn't see a significant difference, but we were expecting to see some of the results border on significance of a higher rate of increase of the temperature during the spike for radioactive sources. We have some evidence of that. It's not very strong. But here in this chart over here demonstrates the difference with controlled data, and the americium beryllium source and the californium source out here. The californium source was on average the water in the presence of that radiation was on average 1 minute, was supercooled on average 1 minute shorter than the control. And so the californium result is a 4 sigma. We usually, in my field, we don't use p-values. But in p-value, that'd be somewhere between this emoji here with the stars and the mind-blown emoji down there. So this is, my wife found this on the internet from the lab of Professor David Nelson. I don't even know what he does. I haven't looked him up. But I love his little emoji scheme for p-values here. The Pinocchio, 0.1, 0.05, 0.01 smiley face. So we're somewhere, so 4 sigma is between p of 10 to the minus 3 and p of 10 to the minus 8. So actually, it's 4 sigma when you account for the all uncertainties, including systematic uncertainty. If you just look at the statistical uncertainty, the californium differs by about 20 sigma, so that's well below the mind-blown level right there. So we're definitely seeing a very, very enormous effect here. So given, though, that this could be observation of a new physical chemistry process, though, we want to make sure that we double-check and triple-check and cross-check the result. So we also did an image analysis and see that in the presence of neutron sources, there are more multiple scatter events, as I was referring to earlier. And unfortunately, we didn't have room for 2 cameras. As I mentioned, we use a borescope, the kind that's used, unfortunately, as you know, in colonoscopy and things like that. That's the only thing we could fit inside of our chiller. And so we didn't have 3-dimensional position reconstruction, but we could count the number of scatters, and we can sort of also tell events, surface events, wall events, and things like that, but not so robustly. But we were able to count by eye and actually performed a blind analysis where I renamed all the files randomly so that my team of undergraduate students didn't know which data set was control and which was neutron, and we still see an effect. The gamma data is the error bars overlap and is not significantly different. It seems slightly lower, but not significantly different percentage of doubles. But the neutron data has 6.75% double and triple, etc., snowballs versus control, which is only 4.32%. We didn't stop there, though. We had yet a triple check, which is I mentioned that there was a more traditional kind of radiation detector underneath the water, and we see an enormous coincidence spike where a flash of light in our scintillator underneath the quartz vessel with the water is coincident, happens within a fraction of a second of the freezing of the water. So we definitely have direct evidence here that incoming particles can cause supercooled water to freeze. So what is this good for? I kind of inverted, so this is a water conference and not about a physics, I kind of inverted my usual order of slides in my presentation. So the whole purpose of everything I just showed you, why was I looking for new types of material substrates, and that's what led me to water, was in the search for something called dark matter. So that's sort of been the overarching theme of my work, of my research. And so going kind of backwards now I want to talk about the motivation for what you just saw. So the history of dark matter starts with several astronomers, especially Vera Rubin, who unfortunately passed away only a couple years ago in her 80s, didn't get to live to see a direct detection of dark matter, and Fritz Zwicky, a Swiss astronomer, and Rubin was an American astronomer. So what Rubin did was look at the revolution, the speed of revolution of stars around centers of galaxies. So as we heard earlier today, our sun, is orbiting around the center of the galaxy. It takes about 200 million years. That's one galactic year for our sun. What's really odd is that when we look at our own galaxy as well as others, that there appears, instead of a drop-off in velocity, it increases, and that's not what you'd expect. If we look at our own solar system, the further a planet is from our sun, the center of mass of the system, you get a lower orbital velocity. So this is the opposite of what we'd expect. So this is quite baffling. So one of the ways you can explain this is that there's a spherical halo surrounding flat, even spiral galaxies. And so you have the black hole at the center of a galaxy around which everything is orbiting. But you also have this invisible mass producing, if you can see kind of in gray on the slide, this sphere of invisible mass around the galaxy. Where is that mass? So we can use other forms of imaging modalities beyond optical. So if you look at X-ray, you see that there are X-ray emitting gases in between galaxies where there doesn't seem to be sufficient gravitational force from the stars of those galaxies to be able to keep those gases in place. And to give you a sense of scale here, you're not looking at stars. Each splotch here in this image is a galaxy of hundreds of billions of stars. So this is a large central galaxy in this image, NGC 0507, and has dwarf galaxies orbiting it. So we can also look at something called gravitational lensing. So just like how my eyeglasses or a contact lens can bend light, a gravity can bend light. When you learned in 5th or 6th grade that light only travels in straight lines, that's not entirely true. A gravitational field can actually distort light. And what this creates are these beautiful images where you have the same galaxy multiple times in the same image kind of distorted. And what this distortion allows you to do is calculate the amount of matter there is in the universe. And what you find is that 90% of the matter in the universe is missing. And so the gravitational lensing studies are consistent with the studies of the galactic rotation curves. And then in 2006, this is considered by many the nail in the coffin for theories of modified gravity, is the bullet cluster collision, where you have two galaxy clusters colliding. So again, most of the splotches you see on these images of light are not stars. There are a couple, intervening nearby stars in the camera, but these are galaxies of hundreds of billions of stars you're looking at. And in the bullet, we've analyzed the bullet cluster 3 different ways, using optical visible light, and in blue is the gravitational lensing map, and in pink is X-ray emitting gas. And what we find when we put this all together is it's very hard to explain this picture without there being extra mass. that is not accounted for in ordinary matter, that's producing gravity but not much else, because the center of the blue and the pink and the optical don't line up. The centers of mass calculated these different ways are not consistent with each other. Now, this often comes up, so I love the comic XKCD. They have this great one-sentence joke, Department of Astrophysics motto: yes, everybody has already had the idea, maybe there's no dark matter, gravity just works differently on different scales. It sounds good, but it doesn't really fit the data. I believe we have a certain, Nobel Prize winner here who said yesterday, you don't throw out the facts, you throw out your paradigm. And so we have proven over and over again that we understand gravity very well. Earlier this morning, we heard about gravitational waves. Gravitational waves wouldn't have worked exactly the same way as Einstein predicted if the theory of relativity was wrong. And how many of you here today rely on GPS to get around? GPS probably on your phone or a separate GPS. Well, GPS wouldn't work if we didn't understand gravity, because a spacecraft in orbit has a lower enough gravitational force from the center of the Earth. You actually have to account for not just the relativistic effect of the speed of the spacecraft, but the fact that the spacecraft is faster, is farther from the center of the Earth. So we understand gravity quite well. It seems to work. So attempts to modify gravity to say, no, there's no dark matter, we don't need it, and people have laughed. Many people have laughed at it as the new ether and it's nonsense, but it turns out you can't get rid of it, because while modifying gravity may explain this or this, the rotation curves, is not going to explain all 6 or 7 independent pieces of evidence. Here's another one. There's the cosmic microwave background radiation, which is the echo of the Big Bang. It's a whole field in itself that we could talk hours about, so I just need to summarize the relevant bits of it for you that are connected to dark matter. So these little orange and blue pixels are temperature variations in the sky at less than the 1% level. And by studying the clumpiness, by Fourier transforming this, doing some mathematics on this, and looking at what's called the power spectrum, these peaks develop that tell you the scales of the clumpiness. And those peaks can be translated into the amount of matter and energy there is in the universe of different types. And we get this pie chart, which is called the standard cosmological model. And what we find using this cosmic microwave background, as well as many other independent astronomical measurements like supernova explosions, we find that 69%, a remarkable 69% of the universe is made of something called dark energy, which we don't understand, and we think it has something to do with the famous vacuum fluctuations that we're always hearing about. So the zero-point energy is real, but we don't understand it, and we don't have a mathematical model that explains this percentage and the amount of dark energy we have. But here's the funny part: even though they both have the name dark, I'm not talking about dark energy today at all. I'm talking about dark matter. So dark energy, we know even less about that. We have no idea what's going on there. We have some ideas tied to vacuum fluctuations, but that's a remarkable amount of the universe. So I am going to focus on this. This is the focus of my research, is this quarter slice here, this 25% dark matter. Now, you might look here and say 5% atomic matter. Does that mean we understand only 5% of the universe and that's what makes us up in this room? No, actually, it's much worse than that. So of this 5%, 3/4 of that is hydrogen, and 1/4 of that is helium. So you heard that right, 3/4 plus 1/4 is 100%. Carbon, oxygen, all these things are the sub 1%, just leftover dregs of the universe. All of chemistry and biology is less than 0.0001%. Can't even put it on the pie chart. That's how little we understand of the universe. So most of this 5% is hydrogen. There's neutrinos here, 0.1%, photons, which is light. Every few months you'll see an argument in the scientific community, can black holes be dark matter? There's not quite enough of black. We'd have to be off by a lot on that 0.005% for black holes to explain dark matter. So we're kind of in a bind here. We have this 25%. So we've made, enormous scientific progress the last few centuries, but it's definitely, I say, the height of hubris to think we already know everything. We know less than 5% of the universe. And what we know well, but there's still so much out there that we don't understand, that we're trying to understand. So what does this dark matter do in its interplay with matter? It forms what's called the cosmic web. So dark matter is the reason why you have clusters of galaxies separated by filaments. So you have clusters and voids, and this is known as the cosmic web. And what creates the great cosmic web, we now have, this was quite the mystery in the 1980s and 1990s, but we now have computer simulations that can reproduce. We actually have run computer simulations of the universe from the Big Bang to today. Computers have finally gotten good enough. And this is what's an excerpt from what's called the Millennium Simulation from the Max Planck Institute. And you see that what happens is dark matter clumps first, and then it attracts ordinary matter, which is mostly in the form of hydrogen gas. So dark matter's main feature, we don't know much about it except that it produces gravity. And what's remarkable is now our computer simulations can actually reproduce reality, which is what we actually see. So on the right here is not a simulation, it's an actual map of the visible universe of thousands of galaxies. Now, whenever I see this, I can't help but notice how similar the universe is to the mammalian brain, including the human brain. I don't know if it's a coincidence or just, one of God's jokes or something to make the entire universe look like the brain. But that's what the universe looks like. It's a web-like structure. I still haven't told you though, okay, so what is this dark matter? Okay, as someone said earlier this morning, right? The most honest thing you can say is we don't know. We don't know. But we have some ideas. So we have candidates. So one generic name, it's a vanilla generic name for a candidate is called the WIMP, the weakly interacting massive particle. And one idea to explain the WIMP is that for every particle has a supersymmetric shadow particle. So this is very analogous to matter and antimatter, but the difference here is that you have particles with a different amount of spin, a different helicity, and these particles, not different direction, left versus right, but rather a different amount of angular momentum. And this is different than antimatter because, well, for one, we've been studying and using antimatter since its discovery in the 1930s in cloud chambers. This is still in the realm of speculation. We're hoping of finding a supersymmetry. And the other big difference between supersymmetry and antimatter is that with supersymmetry, it's a broken symmetry. So that means that the superpartners are heavier. So the idea is one of these heavy superpartners, maybe the lightest one, if it's stable, that forms dark matter. This is not a dark matter model. It's just killing two birds with one stone. This is just an independent idea that happens to also give you a nice dark matter candidate. My personal favorite, though, is extra dimensions. So this is the idea where we have, more dimensions of space beyond length, width, and height. And to explain why we don't have evidence of this extra spatial direction, we speculate that it's curled up on some microscopic scale. And if it has a curled up geometry like that, one of the quantum mechanical consequences of that is that you would have, just like with supersymmetry, you have copies of all the standard model particles. And actually, that's called the Kaluza-Klein model, and the first name in that, Kałuża is one of my scientific heroes because he's a Polish scientist. I'm of Polish descent myself. His name, Kałuża, unfortunately means rain puddle in Polish, but all last names mean something, I guess, at some point. So there's no shortage of ideas, though, beyond just the WIMP. So this, again, is from XKCD, but you'd be surprised that actually half of the names here are real. And I would challenge you to figure out which ones are real and which ones are fake. One of my favorite is electrons painted with space camouflage. And then if we go to this end, this is pretty fun. Black holes ruled out by buzzkill astronomers. So all those buzzkill astronomers killing those great ideas. So there's some pretty funny, pretty good jokes on here, space cows. And this is a logarithmic plot versus mass. We really don't know if dark matter is a particle. What's the mass of one dark matter particle? It could be anywhere in this graph. We've been focusing, though, in recent years in this regime, which is around the mass of 50 to 100 times the mass of one proton. So these are the different the different strategies we use for detecting dark matter, and the one that I focus on is direct detection, where a dark matter particle hits a standard model particle and creates an elastic scatter, interacting with the nucleus or with an electron. So think of it as billiard ball scattering. So you have dark matter coming in and hitting one of the atoms in your detector. The challenge is, though, you have to go underground to get away from cosmic radiation, and you also need to eliminate sources of neutrons, gammas, alphas. Radon, which you may have heard of in your basement, right? It's out to get you, is really bad for dark matter experiments. Radon, because it can give you a false positive signal. And when you're trying to detect a new particle, one terrible thing is you accidentally rediscover an old particle and think it's new. So that's one of the incredible challenges. As a result, we have to build detectors and go underground, and also build our detectors of extremely low radioactivity material. So we're talking about building detectors from metals and plastics that are less radioactive than your sweat, or less radioactive than a banana, because we don't want a false positive signal, so we need to really shield our experiments. But now, what does this have to do with water? So to quote Darth Vader, the circle is now complete. So as I conclude in my last 10 minutes here, we're going to tie this back into what are the advantages of using a supercooled water detector, which I've invented called the snowball chamber. My wife, who's not a physicist, actually came up with the name. So the idea here is, with the snowball chambers, to avoid what's called the street light effect, or the lamppost effect, if you prefer. We've been looking for dark matter where it's easy. So in case you can't read this cartoon from the back, the police officer says, "Is this where you lost your wallet?" "No, I lost it in the park, but this is where the light is." So we have, in the field of dark matter, we have a street-like effect where we've been really looking at high masses where it's really easy. But what if dark matter isn't a particle between 50 to 100 times the mass of a proton? What if it is equal to the mass of a proton? In that case, what better element to use than hydrogen, which is just protons with electrons around it? So a hydrogen bubble chamber has been used in the past in physics. I don't think the safety people would really like that at the university. If I had a great big hydrogen chamber, think, Hindenburg and stuff like that. So I thought, what about water? Water's hydrogen rich, and water is inexpensive and relatively easy to purify. It's already been used at the megaton scale. In Japan, there's the Super K being upgraded to Hyper K experiment that's planning to use megatons of water for neutrino experiments. And so this is not entirely a new idea. We already have the technology. But we're trying to make sure, we're looking for dark matter in all the right places. There's this famous cartoon of an astronomer and his wife pointing out that he's missing the comet. That's a French cartoon from 1858. So we're trying to avoid the streetlight effect, where we're looking at the easy region to look for dark matter. So what do the results look like? So I'll explain what a plot like this in the lower right looks like. So this is a cartoon of what our results look like. They're all null results so far. We have not detected anything. But sometimes non-discovery is just as important as discovery, saying that we need to readjust our thinking. So experiments have been ruling out parameter space, making lines on this graph that are lower and lower and lower. So what this is a graph of is the interaction strength of dark matter with ordinary matter versus the mass of one dark matter particle. That's also free parameter. And so if you saw a signal, you make a blob on this plot. Different theoretical predictions, such as from supersymmetry, are also blobs on this plot, and experiments are drawing these curves, and everyone's getting lower and lower and lower in that race to get the Nobel Prize and finally see something. So this is a cartoon. This is a real version of the plot showing recent experimental results and predictions for a next generation experiment called LZ, which I also work on, which uses liquid xenon as opposed to liquid water. That would be the subject of an entire another talk. But the point with water is that can get you to lower masses than traditional technologies. So with water, if we look at the lower region of the plot below 10 GeV, so that's roughly 10 times the mass of a proton, a water-based experiment should be able to do better not only than all existing experiments, but most projected experiments as well. And that has to do with the nature of water because of its hydrogen. So the hydrogen is so wonderful because it's the lightest element. And so it gives you sensitivity to light, dark matter. It also has another benefit. So if you're wondering what is this big yellow region here, which corresponds to this orange here, that is called the neutrino floor. That's where, unfortunately, you've built your dark matter detector too big, and now it's a neutrino detector. So now that's sort of a no man's land where it's like, okay, now good luck ever detecting dark matter. You cannot shield the neutrinos. They will go through the rock of the earth. They will pass through, the famous joke is light years of lead. And so you're not going to shield neutrinos. So neutrinos, which are naturally occurring from the sun, start to interfere with dark matter experiments in this region right here. So you can't keep building bigger. Eventually, you have to stop building bigger and start building smarter. And so one of the things we're doing, instead of just pushing down on this graph, we're pushing to the left. Using water to lower the energy threshold of traditional experiments. So I'm running out of time, so I'm going to skip over the next slide. But we found that there is data on what the energy threshold should be of supercooled water. In other words, how much energy does it take to cause it to freeze? And it seems to be that the answer is not much, which is a two-edged sword. It's both a good thing and a bad thing. It's a good thing because we want to detect dark matter, but it's a bad thing because we don't want to detect anything else. So based on some seminal work by Donovan Barahona, who's a NASA scientist who works on supercooled water in the atmosphere, we think that minus 30 degrees Celsius is probably a sweet spot where we could have an effective dark matter detector, but we're not so cold that it's just triggering on everything. And now we have a useless detector that triggers on every stray radiation. So we need to tackle all the sources of radiation. Neutrons, which I mentioned earlier, we think look just like dark matter, so we have to be careful. Alpha particles, gammas, electrons, and muons, which come from cosmic rays, all could contribute to a false positive signal for dark matter. And so it's an incredible challenge to be able to, and this is one of the other advantages of supercooled water. You'll notice earlier I said that it looks like our detector is not sensitive to gammas and electrons. So that's a huge leg up. If that's true, that means that we could have a more effective dark matter detector. But that's not the only application. I said at the beginning of my talk that supercooled water has interdisciplinary applications. Nuclear security, terrorist smuggling nuclear material, being able to detect that. There's nuclear astrophysics you can do. Cloud formation and climate modeling. So I've talked to colleagues in our atmospheric sciences department. It turns out that this could have an effect on our cloud formation models because now we need to take into account the fact that radiation can cause supercooled water to freeze in the atmosphere. You don't need a piece of dust, as in a traditional cloud formation model. Neutrino scattering is another process we can consider. That's similar to dark matter detection, but there are also biological implications. You may not have noticed, he flashed by really quickly, really small. Do you remember this cute guy from my first slide, from my title slide? So it turns out that the Arctic ground squirrel may supercool its blood during hibernation. This may not be ordinary freezing point depression, but actual supercooling. This is quite a mystery because if it's actually supercooling, one would be hard-pressed to explain the evolutionary advantage of this. You pick up the ground squirrel and shake it, it would freeze instantly. So it's hard to see why that would be advantageous. So it's quite a mystery. And also, how does the brain, especially a mammalian brain, like a squirrel, survive hibernation with supercooled blood and water coursing through its brain? And recently, I've been in touch actually with Dr. Burke Usta of Massachusetts General Hospital, and we didn't know about each other's work, and they've been working on supercooling organs for organ preservation. I got really excited when I heard this, and I started to speculate wildly and extrapolate from that. And I was like, wow, if you could supercool organs, could that mean you could supercool people entirely? And this would solve cryogenic freezing and move it from science fiction into reality. So right now, there are companies that offer you cryogenic freezing. I'll tell you right now, if you're not already dead, you are dead when you're frozen, because what happens when water freezes in the body, it's going to rupture all the cell membranes. So that's really bad. And what supercooling does, by keeping the water liquid, it avoids the rupturing of the cell membrane. So that's very nice. So that's just kind of branching out into the wild speculation there. Supercooling of livers, though, is not wild speculation. That was just accomplished a couple months ago in the United States. So that's actually an actual real biological application of supercooled water. So some near future work to wrap up here is we want to install more cameras and have better simulations of our detector. And with more cameras, we'll have 3D position information. And one thing we're looking at, I was very pleased at some of the things I heard in some talks this weekend, because I was laughed at when I had suggested this a few years ago, is that what if the snow has some memory of the original particle direction and perhaps some sort of directionality to it? That would revolutionize the field of dark matter, because remember that yellowish orange neutrino floor in the plots I was telling you about. If you can point, if you know which direction a particle is coming from in your detector, now you can reject the solar neutrino background, because neutrinos are always going to come from the sun. They're not going to come from the same direction as dark matter. So if there is some built-in information in the snow formation, perhaps in the hydrogen bonding or in the structure as it forms, that would completely revolutionize the dark matter field. So it's highly speculative, but we're going to test this idea by installing multiple cameras and doing very high statistics measurements with our neutron sources. We're also looking to optimize our detector to make it last longer and also supercool more deeply using a hydrophobic coating. So we've heard a lot about hydrophilic, of course, here. We want hydrophobic because if the water is excluded from the wall, if it's a hydrophobic wall, that means that if your wall is slightly scratched, the water doesn't care. It's not touching the wall. And so that's a potential advantage for conquering the problem that any material, quartz, acrylic, is still going to have on the nanometer scale. It's going to have microscopic surface deformations. So in conclusion, we've discovered that neutrons can make supercooled water freeze. That's a new discovery. And we also found they can multiply scatter, which has been seen in other kinds of technologies. It's not new, but not in this kind. We don't know everything yet. We don't have a quantitative measurement of the energy threshold. And this is potentially related, though, to other fields like the cloud experiment at CERN that's studying cloud formation. We thought it was a completely new discovery. I put here rediscovery because it turns out, as I cited earlier, there was Varshnea at the University of India who had worked on this as late as the 1970s, but not with neutrons, but with gamma rays instead. So it's partially a new discovery, but partially also a rediscovery of an old idea. So I'll conclude with, I did have to argue with a reviewer of one of my proposals who said, oh, it's a nice idea, but it'll never work. And so I'll end with this quote from George Bernard Shaw: people who say it cannot be done should not interrupt those who are doing it. Thank you.
Matthew, thank you very much. I would not be surprised if there would be a lot of questions.
I hope so, yeah.
Thank you. I have a question about the gravitational lensing that you mentioned. So you don't need the slide.
Okay.
No, it's okay.
Old habits,
so
yeah.
It's a kind of theoretical question. So it's known that the Earth has an electric field, and at the surface of the Earth, the field is about 100 volts per meter. It's also known that if you have an electric field, it affects the refractive index. Okay. Mm-hmm. So the question is, since the Earth has an electric field, the possibility exists that other planets maybe have electric fields as well. Is it possible that the so-called gravitational lensing is actually due to electric field lensing and has plausibly not to do with gravitation itself?
Well, I think that it's unlikely because it would be a massive coincidence, since the gravitational lensing that we see matches the predictions of general relativity so well. That could be a coincidence, of course, but the other thing is that we're talking about photons, so photon being a neutral particle would not be deflected by an electric field, and so it's hard for me to see how an electric field would deflect a photon, because it's a neutral particle. So, you know, if I put an electric-magnetic field around light, it doesn't do anything, it just keeps going the same direction.
Okay, thank you.
Thank you. Wonderful talk. How well is it understood how the neutrons interact with the water to initiate freezing? Is it an interaction with a single water molecule and that then propagates out to initiate the freezing, or does it interact in some kind of coherent way with a set of water molecules?
That's an excellent question. So I can only speculate, since this is kind of virgin territory. I can speculate based on neutrons doing something similar in superheated water. And in that case, you are talking about not just a single water molecule, a single nucleus inside a single atom, inside a single water molecule. What happens is the neutron undergoes a coherent elastic scatter with one of the hydrogen and oxygen nuclei. And that, if it produces enough energy, that gives a kinetic energy kick to that entire one water molecule that then knocks into the next water molecule, which knocks into the next and the next, and suddenly you have tens, hundreds, thousands of water molecules that have all been disturbed. For supercooled water, there are 2 or 3 contradictory models we found in the literature. There's Pisarev in Russia, Varshnaya in India, and there were several. They're all arguing that this one's right and the other one's wrong. But the 2 main competing models for how to explain why our data actually works is, one is that it relies on heat, just on thermal motion, and the other competing idea is that it requires ionization. That it's not just enough to disturb an atom or molecule, but an electron had to be liberated, and then that electron goes out and does the chain reaction. So there are varying schools of thought on what's happening, but it's happening.
Thank you.
Yeah.
Matthew, thank you very much.
And before we go on, there's a little clarification, just in case somebody doesn't know what it is. These are papers where we collect signatures to help Professor Pollack retain his research facilities, so please sign if you feel like doing so. Thank you. And next I would like to introduce Guancheng Rang, who will tell us about effects of chiral AB potential field and spin polarization on EZ and seal growth. Please welcome.
Hello, everyone. Let me first thank Jerry Pollock for his kind invitation. My name is Chuansheng Ren from Peking University in China. My collaborators are Alexander Spearman from Kazakhstan, Tongju Li from Xinao Limited in Langfang in China, and Kai Tang from Peking University. Here I give the keywords and the graphical abstract of my talk. I will introduce effects of Chiral-Aharonov-Bohm potential field and spin polarization on EZ and cell growth. We have found interesting chiral-specific effects which may be ascribed to chirality-induced spin selectivity and its effects on electron transport chains in cellular respiration. First, I introduce the physical mechanism of the field generator. Electromagnetic field can be reformulated by magnetic vector potential and electric scalar potential. In classical theory, we can carry out a gauge transformation of them, and the fields will not change. However, in quantum theory, because of the Hamiltonian with electromagnetic field, according to Schrödinger equation, the gauge transformation will introduce an extra phase to the wave function. This additional phase factor leads to the AB effect, which says that an electrical charged particle is affected by an electromagnetic potential field despite both the magnetic field and the electric field are zero. A classic example is a solenoid of infinite length. The magnetic field is zero outside of it, while the vector potential there is non-zero. Then the wave function obtains an additional phase factor compared to when there is no power in the solenoid. This corresponds to a movement of the interference fringes. And the spin of particles can also be changed in the same way, which is named spin AB effect. In 2010, an article based on the quantum spin Hall insulator have realized the manipulation of the electron spin by the magnetic vector potential. Here we discuss a more complicated case of vector potential, which has a spiral form. Figure A is an textbook AB effect example of a particle on a ring, except that the particles are replaced by a rotating ferrite ring. Figure B is to move the ferrite ring to the inside of the solenoid. Of course, the magnetic field is not zero now, but it doesn't matter. In figure C, we wrap the front cylindrical coil with a toroidal coil. Then the magnetic field is enclosed in the toroidal coil, and the two coils also have a superimposed spiral vector potential. Now the magnetic field is zero, but the vector potential is not. Then phase shifts are introduced into the wave functions of particles. In fact, the generator also has an alternating electric potential of more than 100 volts, thereby realizing the influence of the magnetic vector potential and the electric potential on the wave functions in the Schrödinger equation. This vertical section shows the contents of the generator. The ferrite ring labeled with the number 2 is made of nickel manganese. It is rotated by the axis. Initially, the ferrite can be polarized by other parts of the generator for months of intensive work and gradually reach the maximum polarization. And silver cup 3 plays a role of a reflector It is also the internal plate of a capacitor. And the 11 is the external plate of the capacitor closed in a ring. The voltage applied is about 100 volts at 4.3 megahertz. Cylindrical coil 4 creates radial vector potential, and toroidal coil 6 creates axial vector potential. The superposition of these two kinds of vector potentials forms a vector potential of a spiral structure. It causes chiral polarization of wave functions of the charged particles. And then the iron shield 7, toroidal coils 9, electric film 15, and tint copper plate 16 protect the field from the electromagnetic field of motor. The chiral polarization is determined by the direction of rotation and the spiral A field. And the right polarity plays a role like yin in Chinese philosophy of nature, while the left polarity lacks yang. And in both generators, iron rings within toroidal coils are magnetized clockwise. The magnetic vector potential is directed into the device. For the cylindrical coil of the right polarized generator, the direction of magnetic field is down, and the vector potential is clockwise. Toroidal and cylindrical coils together create a vector potential with spiral form of right twist. Ferrite rotates also clockwise. And for the cylindrical coil of the left polarized generator, the direction of magnetic field is up, and the magnetic vector potential is anti-clockwise. The two kinds of coils together also create a vector potential, but with left twist. Ferrite rotates also anti-clockwise. And the generator in our research is invented by my collaborator, the Kazakhstan physicist Alexander Spearman. Now I briefly introduce the effects of these two different chiral polarization on easy water, which has been introduced at this conference 2 years ago. We built easy using knife-in membrane like the Euro process. The generator is radiated from the side, and we observe and measure the thickness of the easy state with macrospheres under the microscope. For the control setting, easy is developed and placed for 1 hour without irradiation. Every 15 minutes, we take a picture and measure the mass of easy. In the first experimental setting, the right polarized generator is used, while in the second experimental setting, the left one is used. And for the experimental settings, easy is developed for 15 minutes without irradiation, and then the generator irradiates the easy from the side for 2 intervals of 15 minutes, which is shown in the figure. The upper 2 figures shows the result of the actual easy vise. The growth of easy depends on many factors, so the easy vise at 15 minutes in different settings are not exactly the same. The lower 2 figures shows the normalized growth rate. We could see the right polarized settings show a clear growth slope compared to other settings. This implies it significantly facilitates the growth of easy. On the other hand, the left generator didn't show any potentiation of growth. In several experiments, it even showed a depression effect. And this figure shows the average results of 8 separate experiments. The error bars show that the results are repeatable. And this research is published on the Journal of Physical Chemistry B and has already been repeated by the group of Li Sisen from Taiwan University. He is the former chairman of this university, and Kim Ying-jin from Kim Il-sung University in North Korea. He is a leader of physical research in North Korea. Then we try to interpret our findings from the viewpoint of chirality-induced spin selectivity, CISS for short. Many introductions about chirality has already been given today and yesterday. CISS effect means the probability of electron tunneling through chiral molecules is strongly spin-dependent. Specifically, in the left-handed chiral potential, spin orientation prefers to be aligned parallel to their velocity, which is shown in the right of the figure, that electrons with spin up are consistent with its moving direction. Thus, it is easier for them to transport through the left-handed helix. However, electrons with spin down are more likely blocked. And in the right-handed chiral potential, on the contrary, spin orientation prefers to be aligned anti-parallel to their velocity, which is shown in the left of the figure, that electrons with spin down, which are anti-parallel to their velocity, is more likely to transport. So this is a research direction in quantum chemistry. The postulated reason is that the helical geometry induces spin-orbit coupling. It alone is too weak. However, in combination with the dipole electric field of these molecules, it can induce strong CISS effect. This is the research conclusions from this direction. CISS effect plays a role in water splitting. When the two spins of the reacting OH radicals are antiparallel, the reaction path leads to hydrogen peroxide is more favorable. While the two spins are parallel, the reaction occurs on the triplet case, and the diatomic oxygen is favored. In experiment, the reaction path can be spin controlled by coating the anode with chiral molecules layer. And the interactions of two chiral molecules can be homochiral or heterochiral. For homochiral interaction, the hole attracts the electron of the opposite spin, which is stronger and more stable than the case of heterochiral interactions, where the hole attracts the electron of the same spin. What we want to do is try to interpret our results using this CISS effect. In our experiment, coils create spiral vector potential, and the capacitor creates electric potential. Through spin and electromagnetic AB effect, the ferrite can be polarized, and maybe it can select certain unidentified elements with specific spin. Then these elements can be winded into water. The polarized elements may interact with water, and as a result, the electron transporting from OH radical in water is spin controlled. It has been reported that knifing could induce chirality in photochemical reaction. And Pollock also have postulated that helix structure of EZ may be present in water. Then the EZ layer may grow due to homochiral interactions of plausible helix EZ structure. So this is our interpretations. Before introducing more interesting results, we should stress the effect of CISS on electron transfer. It could surprise the electron scattering propagation just like ballistic transport in quantum Hall effect. That is surprising in elastic collision and reducing energy consumption. This is also conclusions from CIS research. The figure shows the calculated transmission probability as a function of the applied voltage. There are significant differences in transmission probability between achiral and chiral molecules with different strengths of spin-orbit coupling. Electron transport through chiral systems can be enhanced over that through achiral ones by 10 to 100 times. And the lower figure shows the spin polarization increases as the molecular length increases. What is important for biology is that electron transport occurs primarily in and through proteins, for example, in photosynthesis and in respiration. First, we revisit the photosynthesis process in chloroplast, a water splitting complex with photosystem 2, PS2 for short, catalyze a reaction that splits water into electrons, protons, and oxygens. When the electron in a special pigment molecule, P680 of photosystem 2, absorbs a photon, the electron attains the excited state and then is transferred to a chain of electron acceptors. This electron transfer is coupled with the transfer of protons across the membrane. This creates a proton gradient that drives the synthesis of ATP. When the electron reaches photosystem 1, PS1 for short, it is excited again and the electron transport chain continues further and converts NADP plus to NADPH. This is a paragraph from textbook. So what's interesting is in photosystem 1, PS1, each electron moves from one side of the cellular membrane to the other side with an efficiency very close to unity. This occurs despite that the transport length is over 7 nanometers. It was found that the electrons transferred through PS1 was spin polarized. This suggests that CISS is one of the factors that contribute to the high efficiency of PS1. This is the research conclusions of these guys published in 2014. And then now we switch to our recent results related to the electron transport chain in cellular respiration. The electron transport chain of cellular respiration is quite similar with that of photosynthesis. It happens in mitochondria. At the mitochondria inner membrane, electrons from NADH and FADH2 pass through the electron transport chain. It continues until electrons are passed to oxygen, which is reduced to water. Passage of electrons between donor and acceptor releases energy, which is used to pumping protons into the intermembrane space. The proton gradient then drives the synthesis of ATP. This is also a paragraph of textbook. And our research hypothesis is there are also CSS effects in the electron transport chain of respiration process because they are very similar, the photosynthesis and the respiration process. And we can influence cellular respiration through spin control using our chiral polarized generator. We have studied two cases. First, we studied the influence of the spin polarized generator on Arabidopsis salina, which is the model organism of botany research. The seeds were processed according to the standard procedures in botanical experiments. Then the seedling were cultured for 4 days under the condition of 22 degrees and full darkness. The generator left a right polarized irradiated the dish from bottom for 15 minutes every half an hour. In second experiment, we studied ovarian cell HZAM1 of Heliodis zeer. They were cultured for 3 days and also irradiated in the same way. So after cultured for 4 days, the Arabidopsis seedlings of different settings are observed and measured. The first one in the left is the result of the control setting, cultured without irradiation. And the second one is the result of the left polarized case. The length of the seedlings is obviously longer than the control group. And this phenomenon is well reproducible. The third one is one of the results in the right polarized case, which is more interesting, that the growth of seedlings is almost prevented. It is very strange, so I give a picture of another sample of it on its right. And in this case, it is depressed moderately. And the comparison of typical seedlings in these 4 dishes are shown here. And this figure is the statistic result of the first 3 groups. And these are the results of HZAM1 cell experiments. We could see that for the left polarized case, which now is in the left, there are more cells than the control group, which stand for enhanced cell proliferation. However, for the right polarized case, which is in the right, there are much less cells than the control group, which stands for decreased cell proliferation. Furthermore, obvious pseudopod extensions can be observed in many cells in the right case, which I labeled with right arrows. I think you couldn't see clearly. Furthermore, so the right polarized irradiation induces apoptosis and cell differentiation. And these are, furthermore, we measured the mitochondrial membrane potential using fluorescence dye JC1 and a microplate reader. The result is that for the left case is labeled using L. For the left case, MMP is increased compared with the control group, while for the right case, labeled with R, MMP is significantly decreased. A higher MMP implies a healthy status, while a lower MMP maybe implies apoptosis tendency. So we have also measured MMP using flow cytometry, which verified the previous result with different kinds of devices. And then we measure the production of reactive oxygen species using fluorescence dye DCF. In the right case, an increased production for ROS is observed, which is showed by the green light. So now the mechanism behind our results seem clear. As already mentioned before, in our experiment, through spin and electromagnetic AB effects, the ferrite can be polarized, and maybe it can select certain unidentified elements with specific spin. Then these elements can be winded to the cells. The polarized elements may interact with electrons in mitochondria and control their spin. Because of CISS, the electron transport through chiral complexes 1, 3, and 4, which is shown in the figure, are spin polarized. And for the left case, the electron transport through chiral complexes, and for the left case, more electrons are with matched spin. Then the electron transport chain is enhanced, which can improve energy conversion efficiency and enhance proliferation as a result. And however, for the right case, more electrons are with unmatched spin and are likely to be abstracted by chiral complexes, which induces premature electron leakage from the chain. Then some oxygenates are oxidized by the leaked electrons, so superoxide ions, which is a kind of ROS, are produced. The produced ROS will affect some proteins through signal transduction, which make calcium and sodium ions flow to the outer membrane. Then MMP is increased. Note that increased ROS may have toxic effects, such as apoptosis and cell differentiation, which we have observed. And this is what we have found and what is our interpretation. And there are still many open questions in our research. The most important is, what are the unidentified elements polarized by the generator that can be wound out and interact with the electrons in water and cells? And we don't think it is a kind of, for example, torsion field, maybe, because it can be seen by human eyes. At least I can see a little for 3 centimeters, but with other person, they could see, for example, 30 centimeters. And it could also be sensed or generated by hand, and which I have showed this effect to model yesterday. So, and how can they be polarized by the chiral AB potential field? This is related with questions that which particles is it, or composed with what particles? And the important question is how and where the polarized unidentified elements affects the spin of electrons in electron transport chain. For example, what kind of interactions, and can it be modeled by quantum field theory or standard modeled? So these questions we don't know how to answer, maybe could be researched in the future. So this is my contact information. Thank you.
Thank you very much for your very informative research. And the questions now?
Thank you, and thank you very much. If I understood your interpretations correctly, I'm not sure. I thought you were implying in the middle of your presentation the possibility of a chiral nature of the EZ water. And I just want to point out that the chiral nature is actually implicit in the structure of the EZ, because the EZ occurs, as you showed, in stacked layers. But the stacking doesn't occur in register. It occurs in a way in which each layer is slightly shifted from the previous layer. And the shift could easily be to the right, but it could also be equally to the left. So I just wanted to mention that the structure of the EZ, as we've elaborated, has the capacity to show either right-handed or left-handed structure or chirality.
Thank you. I don't know whether the knife-in will influence the chirality of the EZ helix. Knife-in, I don't know. Have you ever tried this?
We never investigated.
Okay.
Thank you. A remarkable series of experiments, truly remarkable. You have hypothesized that the interaction is with the electron transport chain, and that is causing the difference in the results that you see. Do you have any direct evidence that it is specifically the electron transport chain that you are interacting with?
No, still now there is no direct evidence. I want to do this research in the future, so I must think out how to detect this, because they are in the cells, and we should use fluorescence or other methods.
Thank you.
Thank you. That's all.
Okay, our next speaker will be Arjun Reimann, and his title is Water, RNA, and the Essence of Life. And the PowerPoint is there.
Okay.
You can start, bye.
Am I working? Everyone can hear me? Okay, good afternoon, everyone. Please allow me to begin with a brief disclaimer that I am a product of the traditional American education system, and as such earned a degree in cell and molecular biology without ever discussing the role of water. The most abundant molecule in the cell, by a lot, received little, if any, mention in any of the textbooks, manuscripts, journal clubs, discussion groups, or lectures that I was exposed to. So when I first encountered Jerry and his books several years ago, I experienced an internal scientific revolution, a true paradigm shift for me. And ever since then, I've been trying to rehydrate the desiccated biology that I had previously learned. So what I'll tell you today is something of a synthesis of ideas rather than a deep dive into the experiments I've been pursuing lately. And to me, the fundamental question of biology is this one I put up here. What is the essential quality of life? Although this question has been posed by many scientists and philosophers over the years, I chose this particular wording from Albert St. Georgi. And he went on to elaborate by saying that we can easily divide the world into living and non-living. Hence, there must be some quality to distinguish these two categories. So what is it? Many people are under the assumption that this essential quality is replication, and that by extension, they assume DNA is the molecule of life, because it is accurately replicated. Now, I will not dispute that any system that approximately replicates itself will create natural selection and therefore a type of evolution. What I can say is that although this dynamic may or may not capture life in summation, it does little to describe the behavior of individuals, which do not spend their entire existence replicating. For example, in a colony of bees, most of the individuals will never reproduce at all. Yet I think few people would argue they aren't all alive. And even microbes live in environments where most of the cells are not actively replicating. These are known as oligotrophic environments. And they're very different from the rich media that we give these little microbes in the laboratory, where they divide very fast. So the cells of most organisms are mostly water. And in fact, water is teeming with life on this planet, and is what we look for on other planets in the search for extraterrestrial life. The videos of sonically induced water patterns that we saw a few days ago look strikingly similar to many organisms. But of course, water is not the only matter in the cell. There are also proteins. The next biggest chunk of stuff in a cell is proteins. And in tandem with water, they can form polymer hydrogels that behave in various ways that look a lot like living creatures also. These are called coacervates, and they phase separate from the solution and condense organic matter and can subsequently grow in size and even break apart and shrink. So they have this dynamic like cells do. But these physical appearances and behaviors in water of the coacervates are based on resonance, chemical oscillations, and phase transitions. These are universal processes that happen in both living and non-living matter. So DNA replication is an important process, of course, in the evolution of populations, but doesn't help us describe individuals. Water and proteins seem to be the right stuff in terms of organizational form, and they look and act like life. But let's back up for a second. Where do these proteins come from? And how do molecules replicate? The answer to these questions are the subject of the rest of this talk, and the short answer is translation. So what is translation? From a purely mechanical point of view, translation is the process by which sequences in one molecule, this is called ribonucleic acid or RNA, is used to construct another molecule, a protein. This has a corresponding sequence that's related to the sequence of nucleotides in the RNA and is manifested in the genetic code. But when viewed with a wider lens, the translation process is, in my opinion, much closer to the essential quality of life than either the self-organization phenomena of hydrogel coacervates or any molecular replication process. For starters, translation is exclusively biotic. That means it only occurs in living systems, and all living systems depend on it, even viruses, which exist at the boundary of what is considered alive. Second, translation involves molecular complexes of RNA and protein, shown here, that are far more conserved across life than any other molecules, including DNA replication enzymes or anything else. In fact, the tree of life is only possible to construct because there is a molecular sequence that can be compared across any organism, and that sequence is the RNA of the ribosome. Lastly, translation is the defining, constructive, and regenerative process that perpetuates all other life processes, including translation itself. The preponderance of proteins, RNA, and DNA packed into all organisms are constructed, and translation is the means to that end. But we're here at a water conference, so what do translation and the genetic code have to do with water? And to answer this question, we'll need to examine some of these molecules and the code table in some detail. So RNA, like a protein, is a polymer, and it's the next most abundant type of molecule after proteins and water in the cell. The units corresponding to amino acids are called nucleotides. One of these four nucleotides, ATP, shown here, is very famous as the principal energetic molecule of the cell. It's generated by glycolysis and oxidative phosphorylation. It is also used to build the other three building blocks, GTP, CTP, and UTP. Now, GTP is particularly important for the translation process, as well as cell signaling, some of you may know. And both of these purine nucleotides are important for the polymerization of cytoskeletal proteins and the transport systems that rely on the cytoskeleton. CTP and UTP also are involved in many reaction pathways. So thus, as with amino acids, there is no clear distinction between these biosynthetic molecules and the ones involved in metabolism. There's a couple more things I want to point out about these nucleotides with respect to water. First, they're highly water-soluble, but they're somewhat amphiphilic because they have a hydrophobic end with one or more phosphates, and a less hydrophilic end with these ringed bases. Between the phosphate and the base is a ribose sugar, shown by this pentagon. Like amino acids, there's a relative scale of hydrophilicity of these nucleotides, mainly due to size. So the purines with these two fused rings are less hydrophilic than the pyrimidines with a single ring. When nucleotides are attached into a chain, the backbone ends up being phosphate and ribose alternating. Phosphate is a highly negatively charged molecule, and so these strands of RNA are also polyanionic or negatively charged. The spectrophotometric absorbance of these molecules is about 260 nanometers, just slightly shifted from the 270 nanometer peak that we see in the EZ. So single-stranded RNA molecules, such as the transfer RNA that I've shown here, can fold back onto themselves and base pair according to these AU and GC pairs. I've lost my cursor. So here's the secondary structure showing some pairs, and they form these stems, or helices in a 3D model, and loops, or bulges. The base pairing involves water-mediated hydrogen bonding, and not unlike alpha helices and beta sheets in proteins. An important difference is that the GC pair has 3 bonds, while the AU only has 2. So this one is thought to be relatively stronger than this one. These tRNA molecules are between 70 to 90 nucleotides in length, and they form secondary structures that looks like a clover leaf or something more like an L in 3D. The 2 ends of this L are the functional parts. So in the top right, the acceptor stem is where an amino acid is attached, and in the bottom, there's a sequence down here known as the anticodon, which is corresponding to that particular amino acid. And there's a class of constructed proteins that interacts with the tRNA, and these are called aminoacyl tRNA synthetases, or I'll call them tRNA ligases for short for the rest of this talk. And there's about 20 of these enzymes in every cell that bind to a particular set of tRNA molecules. Discrimination among the tRNAs by these ligase enzymes, again, is due to the nucleotide sequence in the anticodon region. Right now, people think this is due to the strength of this bond, again, by water-mediated hydrogen bonding. Each enzyme also binds to the particular amino acid corresponding to that sequence, and then with the help of AMP to ATP plus pyrophosphate hydrolysis, attaches that amino acid to the stem. These tRNA ligase molecules can misacylate tRNAs when concentrations are unequal. So the tRNAs and the ligase enzymes must be constructed in balance, and this is a common principle to all the ribonucleoproteins that I'm going to be talking about. So this process of tRNA loading or charging, along with transcription of RNA and replication of DNA, are among the only cellular reactions that I know of that produce this pyrophosphate molecule. There are many reactions that cycle a single phosphate, that would be ATP to ADP and back. But cleavage of this pyrophosphate means that it is highly exergonic and irreversible. Therefore, the 3 principal synthetic condensation reactions of the cell provide a directionality to the living cycle that I think is very important. Give me a second here, it's not shifting. Oh, there we go. Okay, so forgive this table, I know it's going to be a lot, but this is the genetic code. Many of you might be familiar with the codon interpretation, which I've put in the middle here, but it's actually the anticodon of the tRNA that is more informative of the relationship manifested by water in the genetic code, so I put that as well. So when the code table is organized according to anticodon nucleotide hydrophilicity, that is the purines on the left, less hydrophilic, and the pyrimidines on the right, more hydrophilic. And then you have on top the center nucleotide of the codon, anticodon, and either the last or first, depending on which direction you're coming from. then this pattern of amino acid usage becomes evident. So as nucleotide hydrophilicity increases across the table, amino acids also generally require more water, essentially. There's an empirical experiment that has been done that shows that these amino acids require different amounts of water to interact with these nucleotides. Amino acids are also grouped either by column or these individual boxes according to similar polar or water requirements. So on the less hydrophobic end of the table, over here, all the broadly hydrophobic amino acids are grouped together in the column. Additionally, on the other side, in the corner, all of your charged amino acids are grouped over here. So arginine is your positively charged, along with lysine and histidine, and then in this box over here, we have your negatively charged aspartate and glutamate. The nitrogen-containing glutamine and asparagine are also in this box because they have potentially extra hydrogen bonds that they can make because of those nitrogens. So in essence, you have a hydrophilic corner and a hydrophobic end, and this is manifested in the anticodon hydrophilicity of the nucleotides in the tRNA. There's another point I want to make. There's a stronger and weaker bonds based on the number of hydrogen bonds in these regions. So if you have strong pairs, that is the GC ones in the middle here, these codons are unambiguous. That is, the third nucleotide does not matter. It's going to be these amino acids no matter what. On the other hand, in the four corners, your weak pairs of AU, these all do require third base discrimination, and this last position becomes more important. So there's a lot going on here, but I'll say nucleotide hydrophilicity and water-mediated hydrogen bonding strength of these base pairs are related to the water requirement of the amino acids that are encoded. Ultimately, with assistance from the tRNA ligase enzyme, anticodons within a tRNA choose one of these amino acids based on a similar thirst for water, with similar anticodons representing similar amino acids according to the need of water by the couple. I just want to summarize this by saying that a largely overlooked aspect of the genetic code is an apparent relationship among these di- and trinucleotides in water solution. Or put another way, the genetic code represents the relative interaction of 21 amino acids and 4 nucleotides with a handful of water molecules. So if tRNAs and these tRNA ligases establish the genetic code, then translation is the systematic interpretation of the genetic code. The production of proteins only occurs because there is a system that is able to interpret the meaning of this code, and it utilizes a constructive process. Ultimately, I believe translation is a code for nanoscale water structuring by ribonucleoprotein polymers. And the molecule most associated with translating the genetic code is called the ribosome. Now, the ribosome is thought of as an entity, but it is really more of a massively orchestrated system than anything singular. In coordination with the transcription of 3 to 4 ribosomal RNAs, there are 60 to 80 ribosomal proteins that must be expressed to assemble ribosomes. And these ribosomes contain about twice as much RNA as protein by mass. This, of course, does not include an unknown number of water molecules that are required for this apparatus to function. In comparison to the tRNAs I showed earlier and are also shown in the middle of this figure, the ribosomal RNA contains between 50 to 100 times as much RNA by nucleotide count. And folding of such a large molecule can be assisted by divalent cations, in particular magnesium, which is shown here bridging distal phosphate oxygens of the RNA backbone. This is very similar to the process Jerry described in his book with calcium bridging of protein backbone molecules at negatively charged sites. So the ribosome is divided into 2 subunits, known as the small on the bottom here and the large on top. The small subunit interfaces a template messenger RNA with the tRNAs and the large subunit, while the large subunit is known as a ribozyme because it catalyzes the peptidyl transferase reaction binding one amino acid together in a chain. And I want to point out here that these illustrations come from X-ray crystallography and cryo-electron microscopy data. And so, although they are useful to a first degree, I believe that these dehydrated preparations actually do not reveal the dynamic behavior of these molecules in solution. They're highly multivalent folding, arms and things that can do a lot of stuff when in solution. And so this whole schematic is just sort of something to get your mind going. But the process is very dynamic and probably does not look anything like this, factory-style assembly of amino acids as depicted in a textbook. So for more insight into how these ribonucleoprotein polymers actually behave in terms of water structuring, their formation, I believe, is quite instructive. So ribosome biogenesis begins, in eukaryotic cells at least, within the nucleus in an even smaller region called the nucleolus. The nucleolus consists of 3 layers that are phase separated from each other and maintain a demixed state both within the layers and from the surrounding nucleoplasm. The core site down here is where transcription of the ribosomal RNA happens, and this is enveloped by what's known as a processing layer, where the ribosomal RNA is spliced and some of the bases get modified, and that's surrounded even further by an assembly layer, where all the proteins and other molecules needed are assembled. So how do these 3 layers phase separate? Well, it turns out that there are particular proteins that bind to RNA that when interaction with water, RNA, and these proteins are able to produce droplets with different surface tension and viscosity. So at the core here, you have a very solid-like vesicle. Surrounding it, you have a more viscoelastic type vesicle, and then surrounding that is one that's even more liquid-like. Therefore, these phases are able to stay with a core shell-type architecture that is somewhat stable and yet dynamic, as it can interact with the surrounding water and molecules. Partitioning of these various proteins into the layers also ensures that the different reactions are spatially segregated and timed appropriately for the sequential activity that is required in all these constructive processes. So I want to point out that, generally speaking, RNA-binding proteins contain positively charged arginine-rich domains that interact directly with the polyanionic backbone of RNA. If necessary, additional domains can confer sequence specificity, as we showed with the tRNAs that are able to recognize specific sequences based on hydrogen bonding strength between base pairs. So I've shown this example of ribosome biogenesis because it's been well studied. You can see it actually through a light microscope. So many people have been looking at the nucleolus for years. But actually there's many, many ribonucleoproteins in the cell. Lars pointed a few of them the other day. There are P-bodies, there are RNA granules, there's literally hundreds of different types and more being discovered all the time. So I'd like to suggest that this is probably a general phenomenon. So RNA binding proteins in tandem with RNA and water are able to form vesicles or droplets of many different sizes and have these qualities whereby they form these spatially structured layers that are important in the reactions that are necessary for whatever ribonucleoprotein is being produced. Many of these are much smaller and cannot be seen with the light microscope too, which is why this one has been instructive for me. Now, the scale of biology is one of the most fascinating and challenging things to deal with in terms of reconciling all this phenomena across such a huge size range. Some people who consider themselves biologists work at the scale of entire watersheds or forests. These are known as ecologists. Other people work on individual organisms, zoologists, botanists, anatomists. Some work on particular systems within an organism, maybe a neurologist or a cardiologist. But all of these scales are really relatively huge compared to the scale that I've been discussing so far, which is of molecular biology, shown mostly at the bottom. So starting down at the very end of the scale, the bond length, either between easy oxygens or between carbons in a ring, is somewhere between 0.1 and 0.3 nanometers. The tRNAs I showed you, maybe 6 to 7 nanometers, while the ribosomes in many viruses are about 30 to 60 nanometers in diameter. This is already 2 orders of magnitude to cross, not a huge range, but not trivial. But then to go from that size up to a bacterial cell or a mitochondria, you'd have to cross another 2 orders of magnitude. Eukaryotic cells typically are 1 order of magnitude bigger than that. And then there are specialized cells that can really be huge. Egg cells can be up to 1 millimeter in diameter. You can see them. And then there are motor neurons projecting from your head down to the bottom of your spinal cord, so over 1 meter in length. And it's thought that there's actually more than 1 kilometer of neuronal projections within every human. So how is this behavior coordinated across a huge scale range, from tiny molecular bonds all the way up to meter size or larger, right? Trees can be tens of meters or even 100 meters tall. Right? The 6 orders of magnitude from an atomic bond to a diatom is roughly comparable from that diatom up to the biggest trees. And I believe that this coordinated behavior across such a scale takes place because of water-mediated phase behavior, which is an easy thing to say, but how does it happen? So I like to take inspiration for these things from biology, and one way that helps me to think about this behavior is exemplified by insects, particularly social insects such as bees. So in a process that has been termed stigmergy, bees are able to build elaborate and large honeycombs with no central plan or any authoritative instructions. How it happens is that there are fairly simple rules that each bee follows in terms of where to put the next hexagonal unit of the cell in the comb. Generally, the more sides that are exposed, the more likely a bee is to place the next unit there. So in this way, the comb will grow approximately equally in all directions. But there's also a threshold effect, which is similar to phase behavior. If the comb is above or below a certain size relative to the number of bees, then the bees become uncoordinated and the comb is dismantled, or perhaps a new one is started. So there's a couple key points to take away from this process. One, the system utilizes indirect communication between agents, in this case bees, that sense and modify their environment, in this case the comb. Two, the individual agents themselves are of limited intelligence and have no overarching plan for this structure. However, intelligent behavior, memory, organization, and goal-directed behavior all emerge from the interaction among these many agents in their shared dynamic environment. This process strikes me as very informative when scaling up from molecules to cells, because for a ribonucleoprotein complex, in addition to water, the cell is its environment in the same way that the comb is for a bee. The environment is constructed by the activity of many of these agents, and it is also the place where they reside. It contains them. So what then is the essence of the cell, in my view? The cell environment is a highly ordered water polymer matrix embedded with several classes of ribonucleoprotein colonies that are able to sense and modify their local environment. Each colony is a vesicle containing some ribonucleoproteins and the water that is involved in the dynamic behavior of this vesicle. There are coding colonies, the ones I described today. These are the tRNAs, tRNA ligases, and the ribosomes. These modify the cell according to the genetic code based on the amino acids, nucleotides, and water that they are able to sense. In collaboration with the copying colonies, these are known as transcription or replication factories, these colonies engage in constructing all the molecular artifacts within the cell, DNA, RNA, and proteins, including additional colonies of ribonucleoproteins and cells. So when viewed this way, cellularity can be explained as a phenomenon that emerges from dynamic interaction of water and ribonucleoprotein colonies. Intelligence, memory, and goal-directed behavior all arise as system properties of the cell in the absence of any hierarchically imposed control. So today, in an attempt to rehydrate a desiccated molecular biology of translation, I've identified a few points that I hope everyone will appreciate. And I'm going to attempt to summarize them as a bold new theory being presented here for the first time. And I call it the hydrosome theory of living matter. First, translation forms the core of all processes that life depends on: metabolism, transcription, replication, cell signaling, cytoskeletal assembly, transport, any other process you want to name. Even translation itself all depend on proteins that are produced by translation. This is the ultimate chicken and egg cycle of the cell. 2, RNA is a polymer, and it's got a water-ordering, negatively charged backbone and orthogonal bases that can pair by water-mediated hydrogen bonding. RNA polymers form dynamic extended structures that are augmented by proteins and perhaps ions such as magnesium. The absorbance of RNA at 260 nanometers is strikingly similar to that of the exclusion zone at 270 nanometers, and I'm not sure whether this is due to similar hexagonal ring structures or perhaps direct water structuring of RNA. 3, the genetic code is a physical manifestation of interaction between water, amino acids, and nucleotides. Amino acids associate with a number of water molecules in order to interact with these trinucleotide sequences within the tRNA anticodon region. And the more water molecules that are required by an amino acid for this interaction, the more likely are these amino acids to be grouped together according to a similar anticodon sequence. 4, ribosomes form in dynamic, non-membrane-bound compartments that are tuned to structure water and ribonucleoproteins into these demixed, phase-separated vesicles with a core shell architecture. I'm suggesting that this is a general phenomenon for other, perhaps all, ribonucleoproteins, which I have termed here hydrosomes, and that ribosomal activity during translation also follows this behavior when tRNA, mRNA, and ribosomal RNA hydrosomes are all able to interact. Lastly, the behavior of hydrosome colonies by forming an ordered water environment gives rise to the cell with all its mysterious and wondrous lifelike properties: intelligence, memory, and teleology. There is no master molecule, no instructional authority, or no informational control required to make this happen. So before I close, please allow me to express my deepest appreciation and gratitude to Dr. Gerald Pollack. I thank him immensely for organizing this conference, for inviting me to speak, and for changing my life in countless ways. He has led me to this podium in front of you here today, and I will continue to follow his trail as long as I can. I consider him to be a tireless and inspirational scientist whose vision and fearlessness has given me renewed hope in this modern day of timid and often corrupt science. Next, I must credit Dr. Katie Buckley, another brilliant scientist who, with her tremendous visual imagination, has created the artwork that I presented today. She is willing and able to provide me with extraordinary feedback and assistance, and is always helping me to prepare my many half-baked ideas for public presentation. And last but not least, I would like to thank all of you for your attention, which is both precious and finite. I'm honored to present these ideas to an audience as brave and open-minded as this one. Thank you. I'll not take any questions.
Thank you very much, Arjun. Any questions?
Well, first, thank you so much for your kind comments. The idea of hydrosomes is, for me, a very appealing one. And, you know, I'm reminded of last year's conference where, I think it was last year's conference, where Luke was suggesting that the water comes before the DNA, if I'm not mistaken. And I think the two of you actually share a very similar philosophy about that, which I think is actually right on, so congratulations.
Okay, great. Thanks. Woody, I have a few more things I could say if there's no more questions, and I have time.
Well, thank you. I'm still very stunned by this correlation between the hydrophilic, hydrophobic properties of the anticodon and the amino acid. And I'm trying to visualize how that would work on a structural level when the amino acid is loaded on the tRNA. Do you think that the binding pocket of the synthetase has a uniform hydrophobicity so that it attracts the same anticodon and the same amino acid? But what about the rest of this very large molecule? Or do you rather imply that the amino acid and the tRNA assemble in the same compartment with a specific solubility for hydrophilic, hydrophobic compounds?
So I
the
think,
question whether the binding pocket or the environment determines
I
the
understand
loading.
what you're asking. And to me, these are highly evolved molecules, right? The story of life is essentially the evolution of the translation system. And so the tRNA, I believe, at one point interacted more or less directly, the anticodon region, I should say, more or less directly with an amino acid. And I believe that tRNAs, although they look like an L, obviously in solution, they can go like this or fold, or other things can happen. And I think there's a chance that the anticodon and the acceptor stem at one point directly interacted. And now this process is augmented by this class of tRNA ligase enzymes that facilitate this process, control it, and provide other means to make it happen. Yeah.
Just a comment. The cell, as we said, is a basic unit of life. But inside the cell, all the processes you describe are coordinated. So my suggestion is maybe coordination, harmony, needs waves also, not only matter.
Yeah, I totally agree. And I'm not a physicist, and I've learned a lot about waves and resonance and things of that matter at this conference, and I look forward to reading more about it and incorporating that into this model. There's one guy back there.
So you started your talk talking about life and non-life, and I thought that was very interesting, and you mentioned viruses as the classic gray area. I was wondering, what are your thoughts on I was thinking maybe we need to stop trying to put everything into a binary classification. This happened in astronomy with, Pluto and what's a planet and what's not. But, nature was there before humans and doesn't care what our labels are. Maybe it's a continuum, and even centuries from now, the more we learn, do you think it's possible there'll always be a gray area? For example, if we developed an artificial self-replicating intelligence, like robots, like a von Neumann probe, that wouldn't have a single quote-unquote living cell in it or a single piece of DNA, but it would happily be self-replicating as in mechanical artificial intelligence. Don't you think that maybe it's possible life is a spectrum between 0 and 1 and not just you are or you are not a living thing?
It's an interesting idea, and of course it's possible. I think there's some truth to that idea. But to me, the difference is that life is probably not a material, right? It's a pattern that we observe. And so what is it about this pattern that's different from the other patterns? Or is there one? There may not be. Maybe it's true that life is just a physical thing. It has no difference than non-life, and that's definitely one possibility. But I would argue with the idea that replication is the essence of life. That's what I tried to dispute in the beginning. And I think that this focus on replication is in many ways led us down the wrong path. And that's because, essentially, as I showed in one of those slides, replication is just one part of this cycle. And the real part of this cycle is translation, in my view. And it is a truly creative power to symbolize one thing as something else. And I think this is the essential quality of life. It's symbolism, abstraction. Our famous chef yesterday called it imagination. I think this is a property of life, in my view, that all life does, whether it's a bacteria, a tree, anything you want to name. It has this ability to represent something as something else. And I think this may be the way to distinguish what is living from what is non-living. Thank you.
Thank you very much.
Okay, so we're winding down, and next are the winners of the poster contest. And I should say, which I failed to say yesterday, that the contest is named after Gilbert Ling, who to some of us is a great hero, who is now 100 years old. And Gilbert is probably the person who did the most to convey the idea that water inside the cell, or in biology, is not like water in the glass, that the molecules are somehow structured, as he called them, or organized. So we named the poster award after Gilbert Ling, and we retained that. And this year, we're very happy and honored that Pierre-Marie Robitaille, who was here last year, has donated $1,000 to be divided among the two poster award winners. So we're going to hear 10 minutes from each one, and Anton Fedorenko will be the first, and we'll hear from him now. Thank you.
Hello? Can you hear me? Oh, thank you. Thank you very much for this opportunity to present our poster, and thank you to everybody, really. And also I want to say special thank you to my wife, who helps me with this project and helps me in everything. Thank you. Our poster is about trying, using coherent domain theory, explain, or just to think about how water can mimic the electromagnetic signals of the drugs. And now there is a term for that. People use it in kind of industry already, infoceuticals, like pharmaceuticals, but infoceuticals, which are electromagnetic signals recorded from substances that have healing, therapeutic, or other biological effects. So to help me understand this theory, one of my teachers, Professor Vladimir Voyekov, was helping me to understand the theory, but if I'm telling something wrong, it's not his fault. Yeah, so for example, can see here, water molecules, this is water molecules, particles. And according to quantum theory, coherent domains, if you have two particles, like here molecule 1, molecule 2, and they oscillate, it's frequency 1, frequency 2, and there is external, environmental electromagnetic field, which have frequency 3, and all these frequencies are almost the same. This is just a simplified view. Then these two particles will be attracted to each other. So basically, if our water in some kind of electromagnetic field, then there will be coherent domains formed in the water. And this year was proposed by Emilio Del Giudice and Giuliano Preparata. They even calculated that about 5 million molecules of water can be joining this coherent domain. And why it's called coherent? Because all molecules, again, they oscillate at the same frequency. Each coherent domain has the same frequency. So the next, as also was shown by Jacques Benveniste and Luc Montagnier, that in their experiments, we can dilute substance, and each substance has their unique spectrum. We can dilute it in the water and then record some signal using amplifier and some technology, record it and even digitize it. Then after, if we use this signal and apply it back to just pure water, again with electromagnetic coil, here's what may be happening. Again, we have in water different molecules which oscillate in different various frequencies. Maybe even when we use this vortex thing, we kind of make a range of different frequencies inside of the water. So the signal usually it's a combination of different frequencies. So it's a spectrum, right? Different frequencies. So then the molecules which have in the water, which have close frequencies, and there is one of the frequencies or electromagnetic field which close to their frequencies will form domain with that frequency. So basically when we're applying a range of frequencies, which is like a signal from the substance to water, basically we get coherent domains with oscillate, not all of them at one frequency, but like at different frequencies. Like inside of one domain, there is one frequency, but there's many different domains, and all of them could have maybe like different frequencies. Here you can see on the right side just like a representation. It's like not, doesn't mean it's like a red color or green color. So because one coherent domain is like one frequency, of course. But if we combine all domains now in water and their like frequencies, maybe we could get total spectrum of the initial substance which you used initially to create this signal. And now I want to talk a little bit about what happened next, how this water with coherent domains may influence the body, the cell. There is like well-known theory how actually substance interact with molecule. Is a key lock principle, like mechanical. We should have specific shape of the molecule to interact with the receptor, and like this. But the question: can molecule interact not physically like a shape, but in electronic, electromagnetic way? Like this is just a picture analogy that we can read text with our fingers, touching it, and we can just see electromagnetic wave from the text. And very interesting experiments have this professor, Luca Turin. He actually proved that we can smell vibrations, and he did like very interesting experiment. So he took two molecules, like two different molecules, which have almost same shape. So according to traditional theories, they should smell the same. But they have different spectrum, and they actually had different smell. So then he did another experiment. He took this coumarin, and he synthesized this molecule, which have absolutely different shape, but almost similar spectrum. And he found that these molecules actually smell almost the same. So he concluded like that it's important not to have the shape specific, but electromagnetic spectrum of the molecule to have specific effect. So the question, like, if we know that actually maybe molecule interact with receptors via electromagnetic field, then according to that previous hypothesis that in water we can form coherent domains which in combination can give the same electromagnetic field like initial substance. So maybe that's how water treated with electromagnetic signal influence the receptor. Because we know from experiment, if we have here the substance, we transfer the signal to pure water, and then we treat some biological, like doing some biological experiment, then we could have the same biological effect. So this is like an idea. And I wanted to add that all this technology was, what we're doing actually, we're implementing this technology, and we have now a database of about 560 different signals. And one of our mission is to collect feedback from people. And we also noticed that it's not kind of new. A lot of practitioners around the world using these signals like 10, 20 years before. And what we're doing is actually like adding internet to this to make it more available for people to use it. And so far we're getting like good, like really interesting results. Like you can see here, person used this water with signal, and the allergy symptoms like dramatically reduced like in just 15 minutes. That can be used for animals, like this cat. Oh, sorry, I didn't see anything, yeah? Oh, I'm sorry. I'm showing you, hey, there's nothing. I'm sorry. Yeah, so this is a platform where we collect feedback from people who are using the water with the signals recorded from different substances. And they have really like interesting results. Because we want to like bring it to people, make it like available and public and clear that everybody, like open source project. Yes, you can see more feedback and different publications we put on our platform, Also, I just wanted to notice one thing today. Today, Dr. Oshman was speaking about vortex, and the one thing like I think nobody really like mentions that vortex not just spins water inside, but vortex is an engine. So engine actually emits a lot of electromagnetic field. So we measured this, and the vortex really produce a lot of electromagnetic field. Maybe that's also important factor when homeopathic remedies are created. So it's kind of like illuminate the water and gives us like extra energy to make that transfer from substance to water as well. And last thing, this is just like interesting like video for you to see that to know whole truth, we need to see it from different perspectives. It's just like not really related video, but just maybe interesting to know. That it's the same thing, but you can just see it from different sides. It looks maybe simple, but you turn it. Yeah, this is simple wave, which is not simple. Yeah, this is actually complex. Okay, thank you very much. Thank you.
Okay, thank you.
Thank you.
And so, the next presenter is Paolo Renati, who's working his way up here with his 10-minute presentation. Thank you, Anton.
Thank you.
And welcome, Paolo.
Thank you. Good presentation, fantastic. Sorry, I decided eventually not to prepare any slide because when you try to put an elephant inside a glass, you have some problems. So I decided just to tell you with very few words because everybody of us is also tired and which is the sense of my work and what I'm trying to aim in my research. That is pretty interdisciplinary actually. Yes, the poster that I presented is just something obvious, something that has been obvious for me for years in the sense that water is coherent in at least one fraction of its part is demonstrated, but a lot of evidences. Anyway, as you know, the science needs very little steps to go forward. The picture that I have in my mind is the fact that would be very nice if we were able to build up an epistemological position that allows us to have a coherent and congruent vision, able to describe and figuring out all the levels of reality, starting from really fundamental dynamics in vacuum up to the most emergent aspects of reality, without the ontological discontinuities. This is what I feel urgent because, if today we are still facing and struggling with a mechanistic, sometimes science, it's also because for centuries men have had the habit to divide between also physics and metaphysics, between information and matter, between consciousness and world, between God and cosmos and whatever. Paradoxically, a perfectly and mechanistic vision of reality creates the need of a black box that everybody of us calls in the preferred way. You can say that is chance, you can say that is God, you can say I see that the extraordinarily ordered dynamics that occur in water and in nature for this reason, because water is the connectoma of nature, of biological life, are witnessing that each represented object that we can see in our reality is exactly the result of the relationships. No? There is no possibility to define nothing in itself independently of the relationships. Are the relationships that connotate, that produce what we are looking at, to something that we are looking at, an object. So I'm very happy about seeing that this year something in this conference has changed a lot with respect to the first time when I went to the Water Conference, because it was the 2015, and in Varna it was a very nice situation. I really perceive that now the background beliefs have changed, and certain topics, certain contents are much more familiar to many people, to much many people, and this is a good sign to me. It's a good wish, and in my thesis that I'm trying to complete in my PhD path, I'm trying to connect some fundamental problem in physics, like the problem, for example, of entropy, of the description of Heisenberg uncertainty, with a vision that is able to recognize, firstly, the relationship with respect to the object. And to me, quantum field theory could be a good, I don't know if it is the best, because a good approach to do this, where molecules, for example, is an object, but it's just, it comes after then the field, okay? It comes after, because when I try to describe it is an emergent property, let's say, when I focus my attention on some limited space-time region, of course. And I was saying, I'm trying to connect this also to this fundamental problem, also to the big and vast problematics in the ability that our nowadays science has in face and tackling and dealing with life dynamics. And maybe, as I hinted on Thursday, this is very important, because we could really shift our way to do medicine, science, research, education, the organization of our world, our policy, our culture. I want just to say that we can, for example, imagine a very different view of health and medicine, but in a very deep sense. I explain. If we know that biological systems are, we can say, super coherent system, in the sense that there is no place where water is not in an interfacial state and is not super phase locked with everything else, we can understand that there is no random event in the body. And imagine if we start from this stance, imagine the revolution that could occur in, for example, in microbiology or in molecular biology, if the researchers told, instead of, let's look in the microscopic scales, what is going wrong with this cell. This is the actual paradigm. Imagine what would happen if they asked, being the cell an object that whose nature depends from the relationship, from the semantic, on the the context always. Imagine what happened that if they asked, let's see, maybe also in the microscopic, but of course not only, if I have to consider the context, what is useful for this different functioning in this cell. It's just a little position, it's just changing from here to here, but the perspective that is portrayed and figured out is completely different. Because saying that a cell is, for example, is doing something wrong, this is already ideological, no? Because it's, of course, it's out of the normal, but every response, every event has to be necessarily correlated and coupled with something. No? For example, an antelope activates his adrenal glands when the peril is here. But if I didn't see the peril, I could look at them and say, oh, there is something in physiology that is wrong. It's trivial, maybe, what I'm saying, but just to understand that in biology, the things are working in dependence on the meaning. And I think that this occurs at all levels. An amoeba is able to decide to go towards the nutrition and away from the toxin. And it doesn't have a neuronal system. He's able to recognize sorrow and pleasure. This is pretty interesting, and this can be justified only in coherence. That's why I'm really, really, really trying to push you and diffuse the quantum electrodynamics perspective in looking at water and looking at living systems. Because otherwise we will continue to look at phenomena without correlating in a deep sense that, to me, nature embeds in itself. That's all. I could speak for hours, but thank you so much.
Thank you, Paolo. Thank you. Okay. I think we're reaching the end, and I guess I'm the only one who stands between you and lunch. However, I don't want to end the meeting without getting a bit of feedback on what we should be doing differently next year. I've heard some positive responses mostly, but I just want to hear from some of you who have some opinions about what we might do better next time to improve the conference. And comments on anything you wish. I'm thinking about first the location. Is Germany better than Bulgaria? I think I know the answer to that. But where in Germany, for example, if you have any special suggestions. Also, any changes in format of the conference that you think might be useful. And if you have some suggestions about the types of speakers, for example, it's always difficult to figure out because some of the speakers speak frequently, and if we continue to invite the people who speak all the time, then there's not much opportunity to invite others. On the other hand, the people who speak frequently often have interesting things to contribute. So it's a balance between those two. So I'm completely open. Any suggestions that you might have, please raise your hand and let me hear from you. Okay, we have one here.
Only one suggestion for me is
Yep. Okay, more vegetarian food. Okay, more vegetarian food. Okay, please. Only organic food. Well, for how many people raise your hand if that's really important, only organic food? Okay, about half the people, only organic food. Tom, are you here? Yeah, it is going to be expensive if we do that. Vladimir?
Jerry, I think it can be done already to put on the website the names of all the participants with their addresses. Yeah.
Sorry, to put on the website the
Yes,
names of...
the names of the participants and their addresses, how to contact them.
Okay, so, yeah.
Well, I can answer that. Sometimes we might have some issues with, this. Some people might not agree to put their addresses on a public website. So what we plan to do this year to mail to all of you the emails of all others. So I think put it on the website is not a good idea, but mailing is fine.
Okay, that's a good solution.
You put this tick, all of you, when you registered, so.
Okay, thank you. That
That's
would be
what we'll do.
really helpful. Okay, there's one back there. Were you raising your hand? Okay. Please.
First of all, I want to thank you very, very much. It's the first time I am in this conference. I visit often conferences and meetings and events in the food business. And I already told to the organization that I'm very, very satisfied and was very surprised about the perfect organization. Everything was really very, very perfect. And we are in such a bubble of valuable information, and the way you share this in such an family-driven environment for me was a very special experience. I never lived this that way, and these are all so scientific people together, so mind-driven people for me. And even then, it was the ambience and the vibes you could bring in this conference was really, for me, I was very surprised. And my biggest dream is that I should really be a part of being a builder of a strong bridge between the scientific world and the spiritual world. So next year I should be very happy if we could have some more speakers who speak from the other side, because I think we cannot split anymore these two worlds. We really have to bring from my point of view, the invisible world to the visible world. And with all this information we receive here, for me, the why I am here is to see how I can pack this, how I can brand all this wisdom in workable products for everyone on the planet, because that's why I'm here, because I want to serve the world. I want to support the well-being, the health and the happiness of the people. That's my drive and my mission. So my vision is, how can I go home and how I can help people now, how I can spread my vision and my mission in the world with everything I'm learning here. So I want to build it down to a workable model. So I thank you very much, and it's really an honor because I follow you already many years and some other people, like my neighbor here, and even I'm not scientific, but I could really find here, it's not of studying, but it's the knowing. I could feel in my heart and in my soul the big truth you are speaking here, because this is the truth, and you really bring the key to humanity to save the world, to save the planet, and to save everyone. So your work is invaluable for me. I admire you, and I love you with all my heart and soul, and I'm very, very grateful to you. And to all of you, thank you so much.
Thank you for your comment. Thank you. Okay, we had one comment here. Yeah, please. Oh. Okay, well, Tom is the guy to speak to. Tom, you were out of the room. There was a desire, a strong desire from about half the people to have all organic food. I realize that that adds an expense, but it's something to consider. Okay. And I know food is getting close. One or two more suggestions? Okay, you had your hand up first. Yeah? Yes. We need a microphone. Is there a microphone here? Because otherwise we can't hear you. Okay, your comment about changing the conference and improving it right here?
No, okay.
Oh, no question. Okay, Gina, you were next. Oh, okay.
Okay, thank you very much. I have actually two things. One, a very mundane. It relates to the food. It goes to money. Several of my friends and colleagues, they pointed out very strongly they cannot come because it is way too expensive. We are used to the roughly 500 euros for the registration fee. But maybe I understand it's Germany. The food was very good, but it costs money. I completely understand. Could it be an option to not have the food obligatory ticked for each day, as far as I understood it? And I was shocked. Suddenly it was over 1,000 euros because it was excluding VAT as well. So I was, whoa, what happened? 1,000? That's very steep. So maybe something could be done here that food is not compulsory kind of. I don't know. Several friends said, no, they can't come. It's too expensive. I understand. Things cost money. Yep, I understand. Yeah.
The poorest country in the European Union. Pricing is completely different. Germany is, of course, a completely different platform. We tried to put the best case scenario together and offer all these options. And I understand that many people weren't too happy with kind of being forced into a scenario here. But we had to plan, make sure that everyone gets fed. So that was the best possible option for us. And yes, there is improvement to this. And yes, we're working on some other options to provide, everyone with access to this conference. So again, we're trying. We tried to do this to the best of what our ability was here.
Okay, Bernard, you had another
Thank you.
comment?
One more, yes. Regarding something scientific. I would greatly wish for a much more, roughly said, distinct separation between, in the presentations, between hypothesis, between theory, between private ideas. I think this is how it could be, on the one hand, and between, classically speaking, like in a published way, rock-solid data that can actually cite it and can be referred to. I think there is a very unclear distinction between what is a theory, what is not even a published theory, or what is something, experimental results that we can, out in the big wide world, in classic university settings, we really can cite and refer to without being decapitated. This would be extremely helpful. Thank you.
Yeah. Okay, Gina, you have a comment?
Oh, I just really want to commend you on the quality of the water present. It's really, really helpful. It kept us all fueled through the ups and downs. And if we can maybe find ways to just stick small moments of artistry in between talks or whatever, some way to, keep ourselves fueled through absorbing such tremendous and important information, over a vast amount of time. We're trying to get in so much, and just moments of rest or stretching or artistry or just some kind of rhythm breaks that help us absorb in between talks or in
That's a good idea.
session.
Okay, thank you. Okay, final comment, please.
One of the most amazing people that I've met has been Vida. And I'm sure many of you would concur. And I would just put in a request that you give her a platform next year to actually, because she's standing on the shoulders of Emoto, I believe, and just taking things in a different way. And it'd be so lovely if you could give her a platform next year so that we can actually witness what she's been doing in a more formal way. Sorry to embarrass you, Vida, but you did ask. He asked for comments about next year. So thank you.
Okay, one of the issues is that this originated as a scientific conference, and so many people have commented before that the emphasis should remain on the scientific content, and I hear more from some of you on the spiritual and other content, so it's a kind of decision as to where this conference should go.
And she'll tell you a lot of people have been giving her suggestions about how to marry up the two, so hopefully that will accelerate, and then you'll have a reason to put her on the program. The other thing is just that, seen as the worldwide family is growing, I'm a medical doctor, and I've been so excited to meet other clinicians here, is whether from the website perspective you could have chapters so that we could meet in our locations in between times. Is that a possibility?
Tom, do you want to comment on that? Yeah. With time. Expanding the website is a costly endeavor. I can tell you that because my son is doing it and he needs to get paid. Otherwise, he doesn't eat.
I for one would be happy
For me.
to be. I for one would be happy to subscribe to, the group in terms of having the UK chapter, and I for one would be happy to pay for that, and then know that there are people that are affiliated with the Water Conference that I can meet up with in the UK.
Okay, we will consider that. Thank you. Beverly, you have a comment?
Members, and I'd be happy to start the Google group, and then you would email me and I would put your email in, and there could be different topics of interest that could go beyond the science of water. It's possible.
Okay, I think we've reached the hunger point. Unless anybody has anything really urgent to say, we have a number of good ideas that we can consider. If not, thank you all for coming, and thank you for your wonderful contributions, and we'll see you next year.